So, hi everyone. Thank you so much for joining us for our community day. Welcome. I just wanted to cover some logistics here first. For those of you here, the restrooms are on that side down the hallway. The coffee is on the right-hand side with some breakfast. The Wi-Fi password is right here. At any point, the folks on the Google Hangout have a question, please type it on the chat window. We'll keep monitoring it, and we'll ask questions either periodically or in the end as well. Before we start, I just wanted to give a couple of minutes to Sunil and open it up for us, right? I know we've come a long way with SPIFFE as a community. You want to open it up, Sunil?
Cool. Hello, everybody. Thank you for being here today. For those of you that don't know me, my name is Sunil. I'm one of the co-founders of Sitel, who has been trying to breathe life into SPIFFE from day one. So our first meetup was in December of 16 at Netflix HQ. And at that time, we had, I think, 7 people in the room, 7 pretty influential people still to this day with this project. And so it's been really interesting to see how far and wide this project has come. And it's always, for those of you that have been involved in open source beforehand, it's always crazy when you actually show up at an event and other people show up too. And so I really do want to say thank you to those of you that are here, as well as those of you that are on video as well, for taking the time out of your day to hear more about the project. Today, you're going to hear a lot about the progression that we've made as a community over the last 3-4 months. Actually, the last community day was in December, so 5 months since we had our last community day at KubeCon in Seattle. And there's a lot of good things to hear from us, from our friends at Square, our friends at Uber, and others as well. SPIFFE Inspire, in so many ways, is so critical for these organizations that are thinking about trying to build in a cloud-native manner, much like Google and some of the folks that I just mentioned beforehand. But in so many ways, it's also challenging because it produces and introduces sometimes new concepts to people that didn't realize there was a world like this possible. And I'm telling you this not just from the standpoint of my perspective, but from Sitel's perspective. When we go and talk to large enterprise customers, you could see them gears turning and saying, how is that even possible that I can actually have PKI automatically rotated across 10,000 machines every 5 minutes? You're telling me lies here. But that's the promise of what we're trying to build, right? That's the reality that we have here, and that's why the CNCF, I think, among other reasons, has brought us into their fold, because it does produce that kind of abstraction that I think is going to be necessary for companies. And so it's been really encouraging to see that. And I encourage your participation in this, right? Sitel as one company is involved in really driving a lot of the direction. We have a technical steering committee that's comprised of some great folks from Twilio, Heptio, and Blend, and a few other places as well. But we really need you, right? We need your brains. We need your perspective. We need you asking, why does this work this way? Because this is not built on 75 years of work. This is built on 3 years of hard work by a few people who constantly want to be questioned, who want to make sure that we're doing this the right way and that it's flexible enough for all of your use cases. So I encourage you to join the Slack channel. When we have community days, when we have meetups, when we have our special interest groups, join it. Ask questions. There are no such thing as stupid questions in our sakes by any stretch, because we've asked a ton of them over the last 3 years ourselves. So with that, I want to just say thank you to Jeremy, thank you to Pinterest for hosting us today, and thank you to Umair very much for pulling this all together. And I'll let you guys to the rest of your day. Thank you.
Thanks, Sunil. I also wanted to introduce the co-organizer, Evan, as well. Evan's right here. He's going to help us manage the event. I think one thing in the past we haven't done before, I think we need to really amplify our message about the community, right? So if you guys can share your thoughts around with the hashtag #SPIFFEDay throughout, share pictures, share thoughts, let's spread the message, right? And tag the SPIFFE handle as well. for the Twitter folks. With that, I wanted to do some introductions from the audience here. And first of all, like Sunil thanked Jeremy and the Printers team for helping us, giving this cool space, hosting it, helping out with a lot of organizational stuff. But for those of you who don't know, that Printers has been an advocate and implementer of SPIFFE as well. I just wanted to give a couple of minutes to Jeremy just to talk about A, thank him and his team, and B, give him a couple of minutes about why what their interest in SPIFFE is. Jeremy.
Yeah, so I'll keep this brief so we can get to the exciting community updates and everything. But first of all, thank you everyone for being here. Pinterest, we've sort of been a participant in a lot of these community days over the past year or so. And we're really excited to be a part of this community and sort of active people in the conversation around identity. So we've been using SPIFFE, I want to say, in production for about 6 to 9 months. We're working on sort of building up our deployment of that over time. I will say, so we're adopters primarily of the spec itself. We're not necessarily users of Spire, but we do advocate. It's a great open source project for those that don't sort of have existing infrastructure to solve some of those problems. So with that, I think I want to hand it back so we can get on to the exciting announcements and everything.
Great, thank you. I did ask for some community announcements before. First of all, Ken from ThoughtWorks, do you want to introduce yourself and your interest in SPIFFE?
Sure. Hi, I'm Ken Adler from ThoughtWorks. If you don't know ThoughtWorks, we're a community of about 6,000 passionate individuals whose mission is to revolutionize software design, creation, and delivery while advocating for social and economic justice. Some of our famous people include Martin Fowler, Aaron Swartz, and Ole Bryn, who's sitting in an Ecuadorian jail right now, connected with the whole WikiLeaks thing. But besides that, our interest in SPIFFE has been from an early day, and my specific, I believe in all of the sort of different use cases, and we'll see it across all of our different customers, but the specific hair on fire problem that I've been trying to solve really is around allowing on-prem legacy services speak to the microservices that we write for customers that are all in Kubernetes and Istio. And that's sort of the challenge, and rotating the PKI, of course, as was mentioned before, is sort of the ultimate challenge that always seems to bite people in the butt when they're implementing these type of things. So that's us. Thank you.
Thanks, Ken. Next up, Mark just walked in, I think, right? Yeah. Right on time.
Hey, I'm Mark Lakewood from Twilio. I guess we're really excited about Twilio. Obviously, at Twilio about SPIFFE and Spire. Obviously, the normal things: service to service, identity, authorization. We're really looking at how we can use it when kind of our AWS primitives fail to support the use cases that we have. And yeah, just really excited to get it started.
Great, thank you. VMware, Deepa, do you want to introduce yourself? I know Neil couldn't make it.
Sure. Actually, we also have Sojo, who's dialed in remotely.
Okay.
So I'm Deepa, and I have a counterpart in Spain right now by the name of Sojo. Both of us represent NSX Service Mesh, and we're looking at SPIFFE Spire, exploring it to see whether it can provide the identity for federated environments. So glad to be here.
Thank you so much. I know, Tiger, Spike, are you on? Can you unmute?
I am.
Perfect. Do you want to take a couple of minutes?
Sure, yeah. So I'm Spike Curtis. I'm from Tigera. We, as a company, are interested in Kubernetes networking, and in particular in Kubernetes security. I have a particular interest in zero trust networks. So I am a SPIFFE maintainer and also one of the co-leads of the Istio security working group. Our interest in SPIFFE stems from this idea kind of historically with Tigera and with Calico. We started off enforcing our policy at the network layer, looking at IP addresses to decide what was allowed to go where. As threats have gotten more mature and as the kind of overhead of crypto has come down, we see a lot of interest in people taking the next step and going up to kind of strong cryptographic authentication of the participants in these network communications. And so that's where our interest in SPIFFE came from. Kind of got started pretty early on with doing integrations with Istio, and I'll be talking a little bit later today about getting some stuff working with Spire.
Great, thank you. I know Ram from Pure Storage, he messaged he might be late, so I'll skip it for now. Anyone from Small Step? Yep, you want to take a minute?
Hey, I'm Sebastian. I work at Small Step. I'm the CTO. And we are also working on service-to-service mutual encryption, mutual authentication and encryption. Essentially, what we focused on is also putting open source software out there to make that happen, and really interested, in participating in the SPIFFE standard and standardization in general in that area, because we think that MTLS and the broader use of PKI for non-trivial distributed systems is a good thing, and we need to do more of that. Yeah, so I'm here. I think my coworker Mike is going to join us too. He's just a little. I think he has a doctor's appointment or something. Mm-hmm. Yeah, so cool to be here. Thank you.
Thank you. With that, the agenda will talk about, Andrew's going to shortly talk about SPIFFE vision and roadmap. We'll share some project updates. Evan will do that. We'll take a short break. Then we have end users talks from Uber and Square. We have a talk by Cloud Entity as well. And then in the end, we have the cool stuff, the demos, right? At any point you guys have any questions, just type them in the chat window. We'll monitor it periodically and see if we can answer them as we speak. And you want to take over? Oh, you don't need this.
I don't.
Yeah. Just
All right. Can everybody hear me okay? Excellent. So I'd love to, I won't take up too much of your time because I think we all want to get to the meaty, interesting, fun stuff. But I did want to play a quick game with you all. I think most folks who've joined the Hangout channel now have done so. But if anyone comes online and they, what I'd like us to do is to give them a big welcome so that when they join, we all shout out their name together. So if you could follow along with me, that'd be great. So I just wanted to give a quick kind of update on a very high level update on where SPIFFE's been in the last few months since we had our last community day in November, and a little bit of a sense of where we're going. I'm not going to give too much detail. I'm going to leave that to the folks who've actually worked on it to get into the gory meat. But I just wanted to give folks a kind of snapshot before we go deep. And so first of all, I wanted to kind of give you a sense of where the community and the project has been going, just in terms of contributors and people. And I had a quick look over the list of people in Slack who've joined since we had our last meeting back in November. And it was well over 100 people, the vast majority of whom are all security engineers, so people who care very much about the details of this stuff and how it actually works, and care a lot about first principles. And I looked at where some of these folks are coming from, and it was this, not surprisingly, it was this, really interesting, rich set of folks from, on the one hand, from vendors who are potentially interested in implementing parts of this as part of their own products, to strengthen their own products, maybe even to expose parts of these standards and tools to their own customers, from a bunch of pretty well-known brand names, particularly in the financial services space, to systems integrators and other folks as well who just have a vested interest in PKI done right and security done right, and this fundamental idea of workload identity done well and done robustly. So that's really exciting to see. On the terms of the project itself, this is just some graphs I pulled up last night on Spire. And you know what? It doesn't really matter what metric you pick, whether you pick stargazers or you pick forks, or you pick lines of code changed, or you pick just number of committers or number of PRs. The metrics all look kind of the same. We've been steady up and to the right, pretty much throughout the lifetime of this project. And in the last 12 months, even more so really in the last 3, we've more than doubled in size according to most of those metrics. And I don't pay a lot of attention to the number of people who start a project necessarily, but it is nice to see that there's that steady continual drumbeat of interest and growth. Public forks is a really interesting metric for me because that means people have not just cloned a project to download it, but they've actually they've made some modifications to it and pushed it up somewhere. So folks are starting to play around with it now. So really nice to see. The more interesting measure of how well, though, a truly open source project is doing and how well a community is doing is, to me, the diversity of the folks who are involved, the diversity of committers, people who are doing the real work to run this thing in production, find the snags, debug the snags, and contribute work back. And a lot of that's in the form of patches and fixes and even sometimes refactors. But there's also been some pretty significant features that have been started to have contributed to the project from outside of that initial core audience of developers, and in particular outside of Sitel. I won't go through this list now because there's partly because by calling out specific contributors, I inevitably miss some people too. So I don't want to spend too much focus on individuals, except of course to say thank you, first of all, to everyone who's been involved in this, both people who've contributed pull requests and patches, also to people who've reviewed them, people who've been involved in counter reviews and the inevitable designs and discussions. It's been really pleasing to see more and more folks from, again, a broader and broader audience, not just try it out and use it and talk about it on Slack, but actually contribute back. In fact, I think in the 0.8 release, I was helping Evan with the blog post a couple of days ago, and we realized of like the headline features that we wanted to talk about, I think more than half of them have been contributed by people outside of Sitel, which is really cool to see. And then, of course, there's a whole bunch of work that's been happening in the background as well, particularly around Spire. There's been some wholesale refactoring of some pretty major components that we'll talk about a little bit later today. There's been some significant work around scalability and security that we'll talk a bit more about later today too. But the broader point here is that it's a much richer, it's increasingly a richer and more diverse community. And to me, that's what's really important. That's what makes the health of a project as well. I also want to give a shout out just to the civility of the project. I've worked on a few open source projects in my time, either as a product manager or as a developer, or I've just been a user. I know most folks in this room have as well. We've all seen what the tenor of an open source community can get to sometimes when you have deep architectural divisions and differences of opinion and differences of motivation. And what I've been personally really gratified to see is a very respectful and constructive and as well as rigorous set of debates and discussions around the points of Spire. That to me is the thing that I personally take away from the last few months more than anything else, is that we've been able to maintain and grow that civility. Hard to show that on a graph, unfortunately. But I wanted to give a shout out as well to a bunch of folks, including Matt and Tyler and Evan and Andrew Harding and a bunch of other folks who've done not just the technical work to help keep this thing going, but have also done so in a very open, respectful, and introspective way. So thank you guys. Very briefly, again, we're going to talk a lot more about this in the coming slides, so I'm going to keep my part brief. But I wanted to give you a little bit of a sense of both what we've been doing and where we've been going since we last met, really. There's a lot of work that's been happening around Spire since we last met. And again, we'll talk more about that in a second. But there are a couple of key themes over and above all of the pull requests. And wait a second, everyone. Who is that? Rupert. Rupert. Everyone, hi, Rupert.
Hi, Rupert.
Excellent. So there's a lot of key themes. There's a couple of key themes that have really come out for us over and above all of the fixes and the pull requests and the refactors. One of those, and in fact, the two big themes really have been usability and security. Obviously, we're a security product, so we care about security and improving it wherever we can. But another thing we've started to come back to increasingly in the beginning of this year has been usability. Just making Spire easier to consume, easier to get started with, easier to work with. That's never done as far as work's concerned. There's always more to do. But even in the last quarter, we put a ton of work into both, first of all, a complete rewrite of our docs, as well as a new docs platform. And some targeted quick starts to make it easier to get up and running with Spire without necessarily having to fully internalize all of the moving parts. We've started to put up more worked examples on how things like, say, Envoy can work as well. And we've got a lot more work to do there around improving that documentation, but that's been a significant focus for us. It's also had us think more and more about packaging, particularly in terms of Kubernetes. One of the things we heard loud and clear was, one of the most interesting use cases of Spire is with Kubernetes, but to actually get it up and running requires a pretty intimate knowledge, not just of Spire, but of Kubernetes itself. And there wasn't a great path to help folks who maybe knew a bit about both, but wanted to really see how these things fit together, to guide them down what, everything from how this thing should be installed, how it should be configured, to how it should be packaged. So we spent a ton of work on that. I know Scott and Andrew Harding and Jenny Beth all put a ton of time and cycles into making that look better. And it is now easy enough that I can do it. That's my litmus test. So thank you for helping bring the bar of expertise down to a chump product manager. I appreciate that. We've also been doing a lot of work around security. And in fact, the Venn diagram of security features really intersects with Kubernetes as well. Kubernetes, quite a few folks from the SPIFFE community have also been involved in several of the relevant Kubernetes communities, including the Identity Working Group and SIG Security. That we've had some discussion and quite a bit of influence in how Kubernetes has improved and refined its own internal security workload identity architecture. And the nice thing is we've been able to start taking some of the innovations that have come out of that and adapting Spire to those. Things like projected service accounts, for example. I'll let folks later today talk about that with more, frankly, credibility, except to say that, as we've been making this thing easier to consume, we've also been making it more secure and solving for a whole bunch of edge cases along the way. In terms of where we're going from here, thinking about this in terms of themes, one of the big themes for us has been production readiness. We have more people now running this thing in production and pushing on the edges of it and finding out where it breaks. And so we've been putting that in turn, firstly, surfaces up a bunch of issues. We've been working hard to close those out and keep that active issue count down to something stable. We've also been scaling up our own testing infrastructure. To test something like Spire means testing it in a bunch of different configurations and on a bunch of different platforms. So figuring out ways to implement that, to automate that, and actually pay for that has been a pretty big focus for the group over the last quarter, and will continue to be into Q2. The other piece that comes up more and more is scaling and testing. As the Square and Uber folks talk a bit more about their implementation, you can push them on some of the interesting stories they've come across as they've tried to scale this stuff up. That in turn has led to some pretty important fundamental things we need to think about in terms of the project. We've already been spending quite a bit of time thinking about what HA of Spire looks like. And how you would set that up and run that together. We're making that story more robust as well. But then we've also started to, the community started to align around designs and even some implementation work around nesting of Spire. And fundamentally what this allows you to do is to go beyond a single HA cluster that might run in a single region or a single data center to running having a contiguous trust domain, for those who know what trust domains are, but over quite heterogeneous infrastructure. The other thing we've been working around which is a scalability benefit, but provides a bunch of other benefits as well, and is a really interesting area for the project, is around what we call federation. Federation is about being able to take, well, actually, I'll talk a little bit about what federation is. It's a nice complement to nesting in many ways. So we've anticipated for a while that with Spire, you might want to run multiple Spire servers in different environments. And you might want to do that for availability. You might also want to do it because you have two Spire servers run by two very different teams that want to own their own security infrastructure. They want to own their own signing keys. But just because they run their own infrastructure, all these things are segregated for whatever reason. That doesn't mean that two workloads that have been identified by those Spire implementations shouldn't be able to trust each other. So we designed federation in part to be able to allow two independent Spire deployments to be able to peer together and establish trust. We realized pretty quickly, of course, there's no reason to limit that to just Spire. If we can roll up the work around federation into the SPIFFE specification itself, then any compatible piece of infrastructure that's issuing workload identities can start to establish trust between them as well. We've started to talk to quite a few folks who have either SPIFFE implementing, either already have infrastructure today that's implementing SPIFFE IDs, all folks who just identify workloads in general about this specification, and we've been grateful for their design input and contributions. But the goal here very much is to be able to start federating, being able to have SPIFFE IDs be more generally useful in a much broader range of environments. And we've actually realized as we build out the Federation API and the design, there's this, Federation is not a new idea in the identity space by any measure. There's a lot of prior art. We've been able to borrow quite a bit from those elements of the OIDC spec that do Federation as well. And that allows for some interesting use cases for, and I'm going to caveat this with the broad word compatible, but compatible OIDC providers and being able to use SPIFFE IDs with them as well. So that's this work is all in flight right now. Evan's going to give a bit more detail on, as a part of the SIG spec update on where we've been going with that and where we're going next. But I just wanted to call it out as sort of an area of focus for us, both over the last quarter and also over the coming quarter, as a really exciting way to expand on the value and the meaning of what SPIFFE and Spire can do. And so with that, I'm going to sign off and hand it over to Evan to start talking about some real technology. So thank you.
Actually, you don't podium mic. Yeah. All right. Hello, everybody. Thanks for coming. So I just wanted to give a quick update on what SIG spec has been up to over the last several months since we had Community Day. So those of you who don't know, SIG spec is short for SIG specification. This is kind of the community group which maintains and writes the SPIFFE specification set. So the last time that we spoke, we were working on JWT SVID. That work was nearly complete at the time and is now fully complete, has been for many months. And there's a Spire implementation available for this that will allow you to cut audience-specific JWTs and then also validate these JWT SVIDs using the same API. Most of the time since last Community Day has been focused on Federation, as Andrew kind of started to touch upon. That draft is now fairly stable. There's not a lot of movement there anymore, so I expect to have a PR up to officially add it to the SPIFFE specification set here in the next few weeks. And when I say Federation draft, it's kind of important to point, like, the document is actually not called like SPIFFE Federation or anything like that. It's called the SPIFFE Trust Domain and Bundle document for a few reasons. The first is that it kind of defines the logical semantics of a trust domain and how it relates to a bundle. So where we went back and forth on exactly what this should look like, and what we kind of ended up with was this one-to-one relationship with a trust domain and a bundle, where there can be many keys in a bundle, and a single trust domain is always represented by a single bundle. That's not to say that a single bundle can't represent multiple trust domains. But when you talk about a trust domain, there should be an idea that there is one bundle. And this bundle essentially contains like all the public keys for the signing authorities that live inside this trust domain. And so this bundle I'm talking about, we've defined it as the SPIFFE bundle in this document. And it's important to understand that this is not necessarily a bundle that you're giving to a workload. SPIFFE has multiple different document types. So right now we support like X509 document type and JWT document type. In the future, there may be more. So this bundle is kind of a way that we can represent signing, like authority signing keys in a flexible way that is not necessarily tied to a specific document type, right? In order to do that, we modeled it as a JWK set, which is what some of the OIDC stuff currently uses, which was a really, really good fit for us in particular, because it didn't have to reason necessarily about document types. Instead, we could just embed these keys as like a flexible like envelope format, if you will, for us to communicate sets of public keys. And so in forming the bundle in this way, we also kind of took another page out of OIDC's book with the JWK URI semantics. So this is essentially saying like, hey, it was a simple JSON document that has the signing keys. We can make it available on a TLS protected HTTP endpoint or something, and we can accomplish federation in this way. So we also recognize that there's probably a lot of different use cases for this. Like some people may not want to use TLS HTTP. Some people might want to like shove it into an S3 bucket every so often, or some people might want to like shuffle it around through like custom distribution mechanisms in their infrastructure. So we didn't want to like mandate those TLS HTTP. So instead we just like provide the guidance and say like, well, we recommend that you just do it this way so that everyone can have a good day. And similar with like how you actually authenticate to this thing, the first time that you communicate that to that endpoint, there's like this bootstrapping that has to occur. So in OIDC, normally you do this with WebPKI. Everyone already has like the public CA certificates for WebPKI, and so I can do like regular WebPKI secure naming stuff and like hit this endpoint and know that you got to the right one. That's not always the case, though. You may have systems which don't participate in WebPKI, or you don't want to participate in WebPKI for some reason, or these systems are air-gapped or offline or something like this. So we provide like another guideline that is, how to use just bare SPIFFE off in order to kind of bootstrap this thing. But I guess like the whole point I'm trying to make here is that, we're trying to be as flexible as possible while still trying to kind of provide light some paths for folks. So, we expect that most implementations will probably support, TLS protected HTTP based bundle endpoints, but you don't have to do it that way, and you can still kind of get the benefit of the SPIFFE bundle. So that document is a public document. If you go in the SIG spec meeting notes, you'll find links to it, and I can share links with you guys if you ask me to. But as I mentioned, we should see a proposal up pretty soon, and I'd really encourage you guys to have a look at it and give some feedback. We're trying to make sure that it's flexible enough to meet everyone's needs, and we've been doing some reviews with some of the Google Istio folks and others who are kind of have some vested interest in seeing this thing work for them. So we welcome all feedback, any and all feedback. So please do take a look at that in the next couple of weeks if you can find some time. I believe that's all I have for SIG spec updates. I want to just pause for a second and see if there are any questions either here or on the call about how this trust domain and bundle specification is laid out, or any kind of details on that. Okay, awesome. We also wanted to give some project updates on Spire. I'm going to kind of kick this off and then pass it off to Andrew to give you a bunch of really interesting, meaty details about what all's been going on in the Spire project since we last met. But I wanted to kind of just start with some high-level stats. In the past several months since last Community Day, we've had over 120 merged PRs across 3 releases with 18 contributors and 13 major features. So we've had a lot of great work going in. Andrew will talk about some of the stuff that has gone in and will be coming up. We also did a lot of work on like getting started guides. We have a new website now, all that kind of stuff that Andrew was mentioning. We have a great getting started guide for Kubernetes. We have one for just like regular Linux deployments, so on and so forth. So if you haven't been to the website since last Community Day, I recommend you go check it out and see what's there. But we're really kind of just to drive the point home that Andrew is trying to make. Like since last Community Day, we've had a lot of public engagement and a lot of external contribution. So the project is definitely very, very healthy, and it's super exciting to see all this stuff get lit up. So looking forward to 0.8, Andrew will come, and we've been working on this release for a few months now, and hopefully nearing an end, but there's a lot of exciting stuff that Andrew will kind of walk you through what you can look forward to expecting.
Hello, everybody. So I'm just going to highlight a few of the features that went in. Like Evan said, we had over 13 major features that made it in, a bunch of PRs. I'll just give us some quick highlights. So for the 0.8 preview, Spire got 2 extra upstream CA plugin types. The first one is an AWS Secret Manager upstream CA. Currently in Spire, or before this in Spire, we just had the single CA upstream CA plugin that would pull the CA certain key off a disk, and so that stuff had to reside on disk, and for various reasons you might not want to do that. And so this upstream CA plugin is able to pull the key pair out of the AWS Secret Manager, so it's never hits disk. We've done a bunch of work around telemetry. Not only going over and auditing all the different telemetry points that are currently in Spire and augmenting those and adding, labels that were meaningful, and just in general kind of beefing up that telemetry story. We also were able to check in support for exporting that telemetry to be a Prometheus, Datadog. What's the other one? StatsD. And we're going to continue to improve this story and really beef up the visibility into what's happening inside of your Spire deployment through telemetry.
Is that both the server and agent?
Yes. Mm-hmm. Yep. So there's a new config section in the HCL that can control this behavior. So nested spires is this concept that this is the other upstream CA plugin that went into Spire. It's essentially so you can organize your Spire deployment into like a hierarchy where one Spire server is able to hand out CA identities to a downstream Spire server who can then, if he wants to sign another downstream Spire server CA certificate, and then, so you can segregate your Spire deployment and provide some isolation and resiliency. And so that feature is going into the 0.8 preview. Got a little bit of massaging to do on that, and then that'll be ready to go.
Is that so you can segregate the trust domain, or is it all the same trust domain? It's just
same trust domain, but each Spire server would have its own intermediate signed by some upstream Spire server. So you can.
So it's more for kind of high availability and scalability.
Yep.
And isolation.
Yep.
Do you support allocations for the intermediates?
So the intermediate. What's that?
Repeat the question.
So the question was, do we support revocation of these intermediates? And I think that we currently don't have an active mechanism built into, we haven't implemented revocation yet, but so these CA identities that are signed by the upstream Spire server, their lifetime is configurable based on your preferences on how long those CA certs will live. And so you can shorten that lifetime up a bit and have them rotating on a frequency to your liking, but we don't have an active way of like pushing out, hey, this one's been compromised and revoking that down throughout the system yet. As far as I know, that work is upcoming at some point. I don't know. Evan might know more about that. So the next kind of major piece of work that went into Spire, we revisited our plugin infrastructure. We kept coming across scenarios where it would be interesting to have plugins participate in functionality within Spire that wasn't part of their primary purpose and identity. For example, we have a whole bunch of different plugin types: upstream CA, key managers, data stores, all sorts of stuff there. But those plugins might want to participate in something like health checking, for example. And so we refactored our plugin infrastructure to allow plugins to offer auxiliary services back to Spire Core. So Spire Core, when it loads all the plugins, it can say, hey, give me all the plugins that support health checking. And then as part of Spire Core's health check, it can go out and talk to all those plugins and get health status back from them. The other thing that this refactor gave us was the ability for plugins to ask Spire Server or Spire Core, both on the server and the agent, for services that the Spire Core can offer to the plugins. For example, this could be something like a metrics host service that Spire Core provides, so plugins can interface with the telemetry system in Spire Core. I'll get into the next feature real quick, and then we can talk about how that relates to this plugin refactor. We came up with a new plugin type to solve some use cases that we had. It's the notifier plugin, and its job is it has kind of two features. The plugin can be notified of certain events, and just as kind of like an advisory, like, hey, plugin, like this sort of thing happened, and it can go off and handle that event asynchronously. And then we for certain classes of events, we allow the plugin to essentially influence the operation. For example, Right now, we only have two notification events wired up and defined so far, and one has to do with when the bundle is first loaded by the Spire server. And if the plugin, a notifier plugin, decided to fail that notification, then Spire server would go down. And I can talk about how we're using that. So we've introduced, as part of the 0.8 preview, Kubernetes bundle notifier plugin. And the job of this bundle notifier, this solves the bootstrapping problem within Kubernetes. So if you have a Spire server with a self-signed CA, when agents come online, they need to be able to talk to that Spire server to perform attestation. And then you need to bootstrap that trust by essentially conveying the trust bundle for the trust domain to that agent so that you can trust that initial connection with the Spire server who's handing out the certificate that it presents during the TLS handshake is an SVID from the trust domain. And so this Kubernetes bundle notifier plugin is notified on Spire when Spire first comes up. It's notified that the trust domain bundle has been loaded, and it goes out and it pushes the contents of that trust bundle into a Kubernetes config map. And the agents then that come online can mount that config map and have that trust bundle material available for bootstrapping. And so the host service, we talked about, the host service is provided by Spire Core. Spire Core makes a host service available to plugins where it can retrieve the trust bundle information from Spire Core and also the server SVID that it could use to, for example, make outbound connections to other components in the system and authenticate with the server SVID to those systems. Any other questions? Yes.
So the notifier plugin, is that right now just like a pre-hook to the trust bundle being loaded by the Spire server?
There is a pre-hook for the trust bundle being loaded. There's also, anytime the bundle is updated by Spire server, the notifier plugin is sent an advisory notice. So at that point, it knows that it needs to fetch the latest bundle and push it up into the config.
Are there plans for other sorts of notifiers like that?
Yeah, so we talked about a bunch of different use cases going into this that aren't implemented yet. For example, what was one of them? The
Certificate transparency.
Right, certificate transparency logs, for example. So whenever we issue an SVID, we want to be able to maybe push the contents of that up to a transparency log.
It's intended as like a general framework.
Yeah.
This is just kind of like the first set of use cases and events, but it will definitely grow over time.
Yeah.
I know we're really interested in getting attestation data out of a notification plugin when a new node comes online, so that we can send that to others as security systems.
Oh, sure. Yeah, absolutely.
Yeah, and we could do a pre-hook on that event too, to like block attestation if we wanted to.
Yeah, that's definitely what I do.
Okay. Yeah. All right.
Any other questions about any of the talks? Anything on the Hangout? Right.
Okay, I'll turn it back over to you.
Okay, so we have a couple talks, end user talks coming up next. Talking about like experiences deploying Spire and some like considerations to be made when deploying Spire, things along those lines. So first up, we have Matt McFerrin from Square. He's going to talk about their experience deploying Spire at Square. Thank you, Matt.
All right. So my name is Matthew McFerrin. I work at Square as a sorry. Oh, I made this thing come up. Can I make it go away? There we go. So I'm a security engineer at Square. And today I'm going to talk about how we're deploying at Square. Okay, first, oh, no. This laptop doesn't have my speaker notes. Does anyone know how to get those? I'm sorry, I'm ruining everything here.
That's fine.
Yeah.
Is there like a presenter mode?
Yeah. Is it just mirroring the screen? Because if you do, I think if I do presenter view, it's gonna.
There you go.
Yeah, it's gonna show it up there. No, that's fine. I'll just wing it.
Do you know how to do this, Jeremy, by any chance? Yeah.
Let's not do this. I'm gonna help you.
So you'll know all the experience.
All right.
That's all I do now.
Sorry. No. Okay. My computer. See, I think it's not. It's using the. It's not using mirroring. It's using the Meet present thing to like present to a.
There's no mirroring options here. Looks like.
So,
do you want to join from your laptop?
No, that's fine. I can just present without notes. Oh,
sorry, man.
Yeah, that's all right. So I work at Square, and we started off as we're a company that provides services to merchants. That started off with payment hardware and the payments backend that powers that. But we've grown a lot. We've got whole new product families like payroll. We've got capital, which does lending. We've got acquired companies like Weebly, which is now Square e-commerce online store. We've got Caviar, which does food delivery. And we've got new product families built inside Square, like Cash App, which is kind of new to us and is providing services to a new class of people, which is to peer-to-peer payments and banking services. So kind of as a result of building all these different product families, some of which have been acquired, some of which have been developed in-house, we have gotten a large collection of pieces of infrastructure. We've got things deployed on AWS. We've got things deployed on Google Cloud. We've got multiple data centers, each of which have different infrastructure inside of them. And there's some common pieces. Kubernetes is kind of the big thing that like a lot of these different places are using as a common factor, but it's not necessarily true. gRPC is a common factor that's used for communicating between things, but it's not always true. We're using Envoy in a lot of places, but again, it's not always true. So we had this problem where we had all these like different pieces of technology, and we are tasked with making them communicate. And in particular, we're tasked with making them communicate securely. So we have all these islands and we need a bridge. We could just kind of cobble things together, build different bridges, but we really want common infrastructure that everyone can work with. And that for us is SPIFFE. So the base problem here that we need is all of these different services need like a name. They need to be able, like, I want to have an access control list that says what is allowed to move money, what is allowed to read someone's email address, what is allowed to decrypt credit cards. And so the fundamental problem that underlies the rest of our security infrastructure is giving services identities or names. And in particular, we also want that to be a cryptographic identity. But I said we have all these like different pieces of infrastructure. So one of the problems we have is that we need some kind of standard. And the like analogy that I like to use internally is that, every country, it issues its citizens a passport. And maybe that, it's a little bit different. The way the passport office in the United States works is different than in Canada, which is different than in Malaysia, which is different than a United Nations laissez-passer, which is like not even really a passport, but it's like mostly usable as one. So there's kind of a common standard that describes this booklet, and like this page 2 has like this like weird barcode on the bottom. And that it's like something we need because, I want my Google Cloud that's running jobs in functions to be able to talk to a Kubernetes cluster running on a DC. And I want that to be able to talk to like an AWS Lambda. And maybe all of this needs to talk to like this weird machine on a factory line in China that's like a Windows 7 machine with some weird embedded hardware that's like plugged into the manufacturing devices for payments. And so I need something that works universally across all of these different things. So I can't just use a Kubernetes service account token because my manufacturing line in China isn't running Kubernetes. And so that's kind of where we like looked around and like we've been cobbling things together, but we want to standardize on something, and that's where SPIFFE comes in for us. So SPIFFE, we're going to give everything a SPIFFE identity. We're going to give everything an SVID, and that's going to underlie the service naming and authentication problem for us. So SPIFFE works really well for us because it's based on things we already use. X509 and MTLS is kind of how we've been doing things. We've been kind of traditionally using something more like the web PKI naming scheme, but that kind of breaks down in a number of ways, and the SPIFFE kind of building on top of that actually works really well for us. So trust domains is a notion that works really, really well for the way we're building our systems. We can kind of have different compartmentalized things. And the URIs work really well because you can kind of extend them, and there's some structure there that isn't necessarily true with the web PKI, where public CAs like don't have a way to impose this thing. So that is somewhere where we can build and kind of integrate with all these different pieces, and it's not tied to any necessarily one of them. But really, the big reason that we're using SPIFFE is actually because of Spire. I think if SPIFFE was just some standard off on its own, maybe we'd be interested, and we were actually. I mean, our internal CA infrastructure has implementations of SPIFFE, but Spire is the piece of software that's enabling us to really deploy this. And it's good because we get all these integrations out of the box. So we're really moving towards Kubernetes at Square, and I can do integrations with Kubernetes, and maybe next week someone's going to decide they want to use something else. So having there's no reason that my integration with Kubernetes has to be different than Uber's integration with Kubernetes. I don't know who else uses Kubernetes, but because it's a shared common technologies, then Spire is a common place where we can integrate with it. So with Kubernetes, that handles the workload registration. We go Kubernetes into the Spire server, and then the Spire server has an agent that's deployed everywhere. And we distribute these identities out to the world. We're going to do more things than Kubernetes initially. We're going to do more things than Kubernetes in the future, but initially we're just focusing on Kubernetes, and then we'll kind of build out support elsewhere. And of course, the big reason for that is that Kubernetes is supported in upstream Spire already. So then we have another problem, and that problem is that okay, we have all these identities issued to the world. How do we use them? So Spire does define a workload API, and some software supports it, including some of our own software. But in my experience running, MTLS for the last couple of years, is that it can be very difficult to get software to necessarily correctly work with it all the time. I have spent more time than I would like with debuggers attached to the Java TLS stack trying to figure out why it is unhappy about something. And so one of our goals from an infrastructure point of view is to have this uniform service mesh, and Envoy is going to be that for us. So we're using Envoy and the secrets discovery API support, which is built into the Spire agent. So Envoy gets a certificate and key from its local Spire agent. It then uses that to talk to an Envoy control plane, and then Envoy control plane tells it what to connect to in terms of the rest of the network, but it also tells it what is allowed to connect to it. And so in that case, Envoy supports a role-based access control, which has a principal, which for us, that principal is a SPIFFE URI. And I think Envoy doesn't explicitly name it as such, but I'm pretty sure that the principal is only usable with SPIFFE IDs or some equivalent thing that looks exactly like a SPIFFE ID that doesn't start with the word SPIFFE colon. So I want to talk a little bit about how we are rolling out and deploying our infrastructure. So the first thing I want to talk about, and we've kind of talked at a very high level abstract notion about trust domains, but I want to talk very concretely because I think this is one of the things we struggle to figure out with is how do we actually set this up? So we are running a bunch of different trust domains in our design. So the first is that we're splitting up trust domains by parts of the company. So our payments infrastructure is going to have a different trust domain than Cash App running their own Kubernetes cluster. That's going to be a different trust domain than Caviar, which actually runs in Amazon ECS, which is going to be a different trust domain from Weebly, which again has their own Kubernetes cluster on bare metal DCs, and also a PHP front end app that's like a big monolith thing. We're also, cross product with splitting by different environments. So payments production and caviar staging are different trust domains, but like payments production, payment staging, payment sandbox, payment development are different trust domains. And then again, cross products sometimes depending on the things with the platform that you're running on. So our payments infrastructure is split between data center, where we're required to have things like fancy HSMs that give us compliance, with cloud products where we want to use things like Spanner for accounting data. So in that case, we could go either way, where we have one trust domain that spans the two, or we could split them. And right now we're starting with kind of splitting them between environments, but it looks like we may do trust domains that span multiple environments in the future, because we want to be able to do workloads that can scale across environments. So data centers for large workloads are much, much cheaper than the cloud, but we might want to be able to burst into the cloud. And that's where we're looking at like Kubernetes Federation as like a place where we can like schedule some workloads on a cloud that, our data center is 2 milliseconds away from US East 1. That's like pretty cheap. We can like, scale out there and not have too much impact from being in different environments, but we do need to be able to assign a consistent workload to one workload which may run in different environments. And again, this is where the trust domain model really fits well with what we're doing. There's also kind of additional use cases. I listed one here, which is Sandbox, which is we have a publicly facing feature where people can use our API, but we don't like actually charge their credit cards because you want to test your, your payments integration and like not have to pay $1 every time you run a unit test. And so that runs, that actually takes all of our software and like runs a second copy of it, except that like the payment gateways in the backend are stubbed out with like a fake one. Now, the problem we have is that maybe sometimes someone accidentally puts the wrong config file in Sandbox. So we want to have a really strong separation between the production payments and the Sandbox, because that Sandbox, who knows what data is in there? It's not going to process payments. Production, that's going to process payments. It should have good data. Everyone needs to have IDV completed. There's real risk of cross-contamination there. So by having trust domains split that and like not federating those, we have like a really strong guarantee at the PKI layer that like no one hitting the Sandbox endpoint is going to accidentally call the wrong copy of a service. They'll call the wrong, Kubernetes service, or they'll call the wrong load balancer. And like suddenly, like because of a bug somewhere in the backend, we're like charging some developer money, or worse, we're like charging one of their customers money, or we're not costing them money, or we're like leaking PAI somewhere because the Sandbox has test features that would not be acceptable in production. So we can use trust domain, like trust domains enable us to build features into our product that are like visible to our customers. And that makes it more reliable to our end users. So I mean, that's something that's like can be really powerful, that most of the time people aren't saying like, oh yeah, security adds features to our customers. I mean, okay, customers demand it, like they don't want us to lose all their credit card numbers, though people still seem to use Heartland payments. Even after they do that kind of thing all the time. But it really builds your reputation if you can deliver these things, and if you can deliver features faster by like providing underlying primitives that work correctly. That's something that actually we want to add some Spire features, because we don't want to have to segregate those by box. So we'd really like multiple trust domains supported in the same Spire agent, so we can have workloads in a separate trust domain from the agent. But that's future features. And development is something that actually I'm really excited about that we haven't yet looked at, but like one thing that we have thought about is if I have a developer laptop A and a developer laptop B, and like, maybe we're working together on debugging a feature, wouldn't it be cool if my services had like a service mesh between developer laptops that came up and was ad hoc? So we've been thinking about something that we're kind of internally calling Mini Spire, or at least I'm calling Mini Spire, where we run a Spire server and agent all kind of in one that is on a developer laptop and can federate with another developer's laptop. We have some like underlying network connectivity between there. And now like I can run a dependent service, and the other developer can run their service, and like they can call my service, and like we can like both have debuggers attached to it, and we can like, we can debug microservice architectures across developer environments. And that's something that's like totally not possible today, but I think is a really cool feature. And it'll like enable better microservice development. Because right now, the way we debug shared problems, like if service A and service B are having a problem communicating, then we have like, well, we run a couple copies of it in the cloud, and then we like set up network pipes and attach debuggers and, you know, hope that we're not interfering with someone else. Or you run everything on one laptop and you have like multiple debuggers running on the same laptop and everyone's fighting over one keyboard. These are like not great experiences. So if we can enable these like on the fly service meshes like in developer environments, that's a pretty cool thing. And I mean, I think traditionally developer environments aren't something that you really focus on securing in the like service mesh point of view, because usually the whole thing is either on your laptop or like on your laptop connected to a private cloud version. I think that's got some really powerful future things we might want to do. So inside these trust domains, we have SPIFFE URIs that we're assigning to all the services. So we are using existing domain names with kind of new subdomains underneath them usually. So like production.squareup.com, there's no action, nothing, like production dot does not resolve. But you know, I talked about kind of on the previous slide, we have like these cross products of trust domains. So actually that first component is service, and that's actually, we have a central service registry, which is like, it's just a Rails app with a database that like keeps track of what all the services are and who owns them, and you know what Slack channel to ask questions about them in, and what PagerDuty you know, schedule to page if something's wrong. But we want to integrate that with Spire so that we can actually kind of validate that this first component in the URI, the service, is actually something in our service registry. And that ties back to kind of the same service is actually more global than a trust domain, which is a little bit weird because I feel like in the kind of the normal SPIFFE world, each service is kind of specific to a trust domain, but we're actually going to have the same service in multiple trust domains, as I talked about different you know, production or staging or sandbox environments. And this way, kind of, there's like a notion that like, you know, maybe you have a staging service that syncs as data from its production version. So we could kind of like hard code some of these notions, but it gives us a little bit of flexibility around access control, where we can kind of know that first element in, at least in our trust domains, I mean, maybe we'll add new trust domains in the future where like this isn't true. I could talk about like, you know, maybe we'll federate with a third party. That's something we've like talked about and people have kind of asked us about, and like, you know, of course, and then the service registry doesn't apply. But certainly at the start, we're going to be doing this where we kind of know that the service is in that trust domain. Today, actually, and part of the reason why is this is how it applies to our existing infrastructure. Right now, we issue certificates with service.global.square, and we use kind of web PKI naming things around it. So kind of we can swap this into our existing infrastructure where instead of service.global.square, we have production.squareup.com/service. One of the things we want to allow is for service developers to partition their own identity. So this is a struggle we've had with our current platform where, and also a service in our case maps to a Kubernetes namespace. So maybe you want to run multiple things inside your namespace. An example would be you have a web server that has like an Nginx that's serving static assets. And then you have another deployment that's like some cron job that's pulling from places and generating those assets. Well, the Nginx is like exposed to the internet. I don't necessarily want it to have permission to fetch whatever the like asset builder is doing. But also at the platform layer, like I don't want to have to know about like what every little individual app owner is using. And you know, maybe today, well, we tell them like, you know, okay, we'll just deploy two services, service 1 and service 2. But then we also have requirements like you have to use RPC between your services, but like that's not great if you want to like, you know, have a shared config map in your namespace in your Kubernetes environment or something like that. So we're going to allow users to subdivide their own namespace just by the pod manifest they deploy. You put a label on your manifest and you can subdivide at will. And that's not something we've implemented yet, and it's maybe not even something we'll get to in a little while, but I think it's a really powerful notion where we can do some pretty cool things. One of the really interesting things that I would like to do with this is actually the CI job runner could say subdivide its identity by like which Git branch it's on or what Git SHA it's on or both. And then you can have things like only the master branch is allowed to upload to an artifact store or to call a signing service. But like that's not something that like the platform layer has. Well, I mean, I guess CI is part of the platform layer, but like the underlying Kubernetes layer doesn't necessarily know about those things. But by kind of allowing an app to use its own knowledge about how to subdivide itself, you can kind of recursively allow service owners more power over how they manage their own application. So there's a lot of moving parts, and I want to spend just a little bit of time talking about where we are and kind of what our roadmap is. So we are currently have test deploys with Spire. We're not actively using it for production workloads. We plan to really soon. There's like a couple blockers, like just like Spire stuff before it's reliable enough for us to get deployed. And I think we've deployed some of these as forks internally, but we're hoping to merge our forked code into Spire. I've got some pull requests open. Just like health checks and stuff is something we really want before we're confident in relying on it, and something that our customers will notice if it breaks. And I guess that's it for me. I don't know if anyone has any questions or how I'm doing on time. I have no idea. Yeah.
Yes. So if we go back to the slides, I have two questions actually.
Here?
Are those two both valid identities in SPIFFE? So you allow like different levels of. So what does the first one mean?
So, right. So we have multiple services, and I said a service in our notion, which is kind of confusing because Kubernetes has a concept called a service, but what we call a service is what Kubernetes calls a namespace. So yeah. So and actually logically, it's actually more than just the deploy platform. It's also like what team is allowed to manage it, like who is allowed to deploy that namespace, but also things like we have like database infrastructure that's not on Kubernetes, and like kind of so the service notion is exposed over there. There's also additional things around like billing and stuff. So it's we're on microservice architecture, so it is one microservice. And so
I can understand the second one.
Yeah.
It's, in the Kubernetes world, it's probably inside namespace called service.
Yes.
And then you have a service, Kubernetes service that is called foo. Is that correct?
So not necessarily. So it's up to the owner of that namespace to decide how they want to use foo in their namespace. So maybe they use it as a Kubernetes service, but maybe they just have an extra deployment. So maybe they have one deployment, which is, so the usual setup is you have a namespace called service, you have a deployment called service, you have a service called service, and everything's just service.
Namespace is a service.
Yes.
Maybe you should. Service should be some other word.
Yeah.
But just any example, right? Like API.
Yeah. App. Well, okay. Let's pretend it says app.
Yeah.
I mean, it's like the term is microservice. Like it is. Maybe I should just say microservice. I don't know. Anyways, so not all of them are micro. Yeah. And yeah. And so right, it's up to the service on how it uses foo. So I mentioned like the CI example, it might spawn a one-off pod or a job in its namespace, which is service / Git master branch / some SHA, and like it can register that workload with that thing, and because it comes off a label in the Kubernetes manifest, it's really however you want to manage your pods.
But there is no hierarchy, right? So this basically they are treated equally. there is no hierarchy under service layer for.
Well, you could add your own hierarchy if you wanted to. Like you could put a slash.
In your case,
yeah.
Is there a hierarchy?
No. So unless that service implements a hierarchy in its own little ecosystem. So in the example of the CI job, which Git repository and then which branch or SHA, that would be a hierarchy, but that's only known to the CI runner, or maybe to other systems which know about it. So you can have additional business logic on top of these if you want to. The underlying platform layer, which is, when I talk about underlying platform layer, I mean Kubernetes, the deploy tech on Kubernetes, Envoy, and Spire don't know about that hierarchy. And in fact, at that layer, we only really care about service. Like that's kind of where we put the strongest security boundaries at the service, the microservice layer. But we try to give some tools to app owners to subdivide themselves if they want to.
It's almost like it's conventional that in your case, a service is corresponding to a namespace. And
yes.
The different version production staging become like some kind of service under that namespace.
Production, yeah.
Yeah, but basically my question is, what about the mesh level policy?
The mesh level policy is just service. It's just at the service layer.
Is there any like the precedence of mesh level service overrides your namespace policy, or what's like a relationship? What's like a, for example, you have mesh level, right?
Mm-hmm.
And you have namespace.
Yeah.
I wish to know what's their precedence. Who takes high priority in terms of enforcement when they are enforced?
So the mesh level knows about two things only. It knows about the trust domain, which is at the highest level, and then it knows about the service or the microservice, which corresponds to a Kubernetes namespace. So we can enforce at the mesh level with network policy in Kubernetes, with firewall levels between clusters, and at the Envoy service mesh level. Those are kind of equivalent, is that the entity that all of those mesh things are using is the service.
Can I ask a more concrete question that I think is the same question? So if you have an entity called service,
yeah,
let's go like, right, and you have an entity that service provisions called service/foo,
yeah,
then at the mesh level, all it understands, it doesn't understand any hierarchy, it just understands there's an entity called service and an entity called service/foo. So if you set up a policy that says the entity service can talk to an entity called payments gateway, the entity service/foo would not also be able to talk to the entity payments.
At least right now, yeah, the service/foo, like we do like exact string matching on the SPIFFE URI. We may in the future like build some more flexible stuff around that. We haven't built that yet, so we're not like really sure. Envoy in particular in its role-based access control supports like prefix matching. So that's something where we may want to use prefix matching, but our central policy database, the service registry, doesn't know about those things, so it can't allow them.
But it seems like the idea behind this hierarchy is to enable that potentially.
Yeah, and that's like something we're thinking about, but like it's not even scheduled work on our roadmap yet. We've kind of started playing around with some designs, but we haven't actually done it yet, except that you could put it in your pod manifest if you want to today. So right now you can only use that for actually communicating inside your own namespace because the mesh layer doesn't know about it yet.
So I was really interested in back a couple of slides when you were talking about this trust domain stuff and using the trust domain as a really good, strong mechanism to break up these environments. One of the things that we found inside Twilio is we have a set of services that are mainly platform services that do actually talk across environments.
Yes.
Have you got a strategy for dealing with those?
Yes. So federation, basically. Right. So this is actually, I mean, something that we haven't traditionally done as good a job as I would like of separating what is like the apps in the mesh versus the underlying infrastructure.
Yes. And
right now it's kind of like a little bit imposed by Spire, the agent and the workloads that the agent is serving workloads from, like they're in the same trust domain. And it is something we would like to split in the future where the agents and the server like are in a different trust domain than like the workloads, the SVIDs they're serving to their workloads. But like that's not something that's supported today, but it's something that maybe in some future not a feature we're currently working on, but some future where that's handled. And so usually the way this works is I labeled the first one here payments, but really it's just like the oldest stuff at Square, which is, I mean, we did payments first. We also did the platform. So that's kind of payments, but also the platform components that are in it. And then, I mean, the same is really true with all of them, that each of these have platform components, but because, and so actually the platform components running, say, the Cash App are actually in the payments namespace, because that's where platform components are running. And that's just, it's like service one is talking to Kubernetes API over here to like provision stuff.
The platform components that run in all of these environments and may have to talk across environment and across department or BU on the right-hand side. They all exist in payments, and you use federation to them to basically get anywhere that you want.
Right.
And if you have something in staging that needs to talk to production for very specific use cases that are very locked down and understandable, then you can federate across like that.
Right, yeah. So for example, an example of something like, in staging, there's like an agent which runs OS upgrades on machines, like keeps components up to date. Like that needs to talk to the production OS upgrader, because that's just how the infrastructure is designed. So in that case, yes, there's federation set up there.
Have you thought about breaking those out into their own trust domain? Because then I assume you'd be able to like federate just that trust domain and still maintain.
Yeah, that's certainly a potential thing that we've talked about, but like we have other stuff to do. Right? Like I want to focus on getting like, first we need to get everything Spire identities, then we can start working on how do we use them in a more flexible manner. And we haven't got to that point where we've like given things Spire identities yet. But like that's the kind of thing where like maybe next year we'll like look at how do we separate platform and stuff. And so probably the way this will work is this sandbox environment, for example, is something where we want to have that on a separate trust domain from like everything else. And then it's like, these are just the sandbox. And then once we've got that, then we have components separated from the platform they're running on. Then maybe we can like start on the rest of the stuff, some separation there. But that's like, I mean, we haven't even done the sandbox separation yet. I mean, partly because Spire does not yet have support for it, but also it's further down the roadmap. But I think that's somewhere that the trust domain notion can help us. We did this in the past with our staging and production environments. We split them by PKI, and it has been a mess. So the way we do it right now is we have like a bunch of different trust domains and applications for like each ACL. They specify like what like file on disk to use to validate it. And so there's lots of like juggling of trust stores around, and like some software doesn't support configuring multiple trust stores, which can be a mess. So you kind of just like end up smushing everything into one trust store, and then you don't have that separation anymore. I mean, one pretty scary problem we've had is like where a service needs to talk to both internal stuff and the external world, but only supports one trust bond, or only supports one like root CA store. So we have to like put our internal CAs and public CAs in the same bundle, but public CAs don't have like the naming restrictions around URIs that ours do. And so, there's some potential cross-contamination there, especially since we have, in the world before GTLDs existed, used things like service.vip, and then it turns out someone went and registered .vip as a real TLD, and now you can get certs for it. So, we've run into some problems like that around configuration and security. So the trust domain stuff will help fix that. So if there's no more questions, I guess that's it from me. Oh, and I think.
Thanks, Matt. Next up, we've got Tyler from Uber, who's going to tell us a little bit about his exploration of integrating Spire with different scheduling systems and the various considerations that need to go into doing that.
Hi, Tyler.
Hello. Okay, so my slides are not in that deck because I was still working in them in the Uber on my way here. How do I steal presentation? Present your entire screen. Yeah, give it to me. Wait, I forgot to click a button. Me now?
Are you in the Hangout?
Boom, there you are.
Okay, cool. So my name's Tyler. I'm a software engineer at Uber. I've been there for a couple of years, worked on a bunch of different stuff. I am actually from our infrastructure group, not our security group. And I'm currently collaborating with the core identity team to support deploying Spire into our infrastructure. And so to just kind of like preface some of the stuff that I'm going to talk about, we have a world where we have many workloads running across some pillars of our infrastructure: storage, networking, and then compute, which I'm talking about a workload scheduler here. And the identity needs to permeate everything. But specifically what I'm going to talk about is kind of how these components work together, where you have the workloads that exist in your environment, and they only need to get an identity, but we need to collaborate in a way with the scheduler that actually schedules those workloads. And at Uber, we have a bunch of different ways of scheduling workloads. So we're going to have to solve this problem a bunch of different times. So first, I'm going to talk about kind of two really high-level strategies for actually propagating registration information of a workload into the Spire ecosystem. And so the first strategy I refer to as direct. We're going to look at this a little bit. So you have your scheduler. You can imagine that being Kubernetes, Mesos Aurora, Yarn. And the very first thing that it's going to do, once you've given it a job and it's decided where it's going to actually place the tasks that make up that job, is it's going to directly create registrations with the Spire server for those tasks. And then once it knows that the Spire server has these registrations, it's going to go ahead and start all of those workloads. And concurrently, once those registrations exist, the Spire agent is going to be fetching the SVIDs that it knows are associated with it. Once that Spire agent actually has the SVID locally and the workload talks to the workload API and does workload attestation, then the workload is going to be able to get that SVID, and for any sort of rotation, trust bundle changes, it's going to get a new SVID pushed to it. So what if you can't actually modify your scheduler? What if you're running Kubernetes and you're like, this sounds like a terrible idea. I'm going to have to upstream all of this super specific code that might take a really long time, and maybe that project doesn't actually want to have deeply integrated. And so you can have this indirect integration, and we're going to talk lots about this. And so in this scenario, the very first thing that your scheduler does is what it currently does. It just starts the workloads. And so to facilitate the Spire ecosystem, you need to build this bridge component. And so the responsibility of this bridge component is to talk to the scheduler and understand what tasks are running where. And so once it actually has this workload information, it can create the registrations inside of the Spire server. Finally, the Spire agent is then able to fetch those SVIDs. And then again, you do workload attestation, the workload's able to get its SVIDs. Now, let's talk a little bit about these two things. So in the direct world, the propagation delay of a registration is completely contained to the Spire ecosystem. And so any sort of improvements made there, you're going to see direct benefit. And it's really easy for the scheduler to kind of understand the bounds. There's a minimal number of involved components, which is great for availability and reliability. The downside is that you actually have to modify this thing, which may not even be possible. Now, in the indirect case, the propagation delay is directly influenced by the bridge component. This could be very minor, or it could be relatively extreme, depending on the sort of integration that the scheduler gives to you. So for example, if the only thing you can do is pull an API, right now you have another knob that you need to turn and a certain amount of load that you're putting on these components because you're just constantly pulling them. If it is a push API, maybe this is actually not that impactful. The second thing is that you absolutely have an extra component in your system now, which fundamentally decreases the availability of the overall control plane. But the great thing is that you can augment any scheduler that exports task information. You don't need to collaborate with an upstream. If it's a third-party closed source thing, you can still make this work. So I started talking about this propagation delay thing. Why would you even care about this? So let's look again at this indirect integration. So the scheduler starts the workload, and now your bridge, let's say it's polling once every 2 seconds, which is relatively quick. So you have an upper bound of 2 seconds for that bridge to even understand the task information. Then we're going to be super nice and assume that the Spire ecosystem is instantaneous. It adds no latency when you actually issue an RPC to that Spire server. And then finally, in the current implementation, the Spire agent actually polls once every 5 seconds. And so the overall upper bound for your SVID propagating from once the scheduler has decided where to place a task to the SVID actually being available to the workload is 7 seconds. So what's actually happening in those 7 seconds? So you have a workload that's running, it's expected to serve inbound requests and it's expected to make outbound requests. But during those 7 seconds, it can't validate the inbound request because it doesn't have a trust bundle. And it can't issue authenticated outbound requests. So it might not be able to do anything at all for these 7 seconds. So now with this in mind, let's go back to this indirect integration and think about what happens if this bridge component is down. So since you don't have a direct integration, the scheduler, let's say the bridge is down and you decide that you didn't know this and some developer in your ecosystem says, I need to upgrade my code. And so they interact with the scheduler and the scheduler starts doing an upgrade and it starts your workloads on a new set of hosts and then they're running there, but they can't get identities because the bridge is down. So these new registrations are not in the Spire ecosystem at all. And the scheduler happily turns off the old workloads. And now your entire service is down and you have a catastrophic outage. So what am I not talking about here? I'm sure there's somebody in the room that's like, he's not talking about something. What is the solution here? It's health checks. Schedulers clearly health check your workloads. So we're going to talk a little bit about what this means using kind of a very simplified model that Kubernetes and Aurora and many other things implement in their own specific ways. So in a very simplified workload lifecycle, once it is placed, once it's scheduled, it enters a starting state. And the only way that it can enter a running state is by passing its health check. And so now the scheduler has some notion of whether or not these new workloads are healthy. And then if that health check fails, it puts it into a failed state and it will reschedule that workload somewhere else. So now if we quickly look at what happens if there's a bridge outage and your scheduler has health checks, the bridge is down, you start doing an upgrade and the workloads move. The workloads do not have an identity and the scheduler is going to stop what it's doing. And so those old workloads, they still have their identity in memory. Those registrations still exist. And you don't have an outage of your service. What you have an outage of is the ability to make changes to your infrastructure. And so you have potentially slowed down the changes that somebody needs to make, but you have your business continuity. Now, there's a very small subset of things where you have an outage that the only way to fix is to roll out code. I admit that that exists, but this is a far less impactful result than the one that we looked at previously. So what are some of the downsides to this really simple model? Let's say you have a Spire server that is completely overloaded, and you're in a situation where somehow that outage has gone on so long that the workloads in your system are actually nearing the expiration of their SVID. And so when that SVID expires, because the Spire server is down, this rotation's not happening, they're going to start getting rescheduled because their health check fails. And so you're going to pile up these new registration entries onto the Spire server, and you're going to have this positively reinforcing cycle that can be extremely difficult to resolve, which we've actually seen even just in our compute schedulers, where things are being rescheduled so much the scheduler itself is having problems catching up. And that can be a very, very difficult thing to resolve. So what about a more sophisticated model? So if we kind of take the model that we had before and we think about adding a ready state, and then the only way that you can transition into that ready state is for your ready check to pass. And this is very, very similar to what the Kubernetes ecosystem does. It separates a liveness check from a readiness check. And then if you're in the ready state and your readiness check fails, that doesn't cause you to be rescheduled. The readiness check determines if you can actually receive inbound requests. So it's a traffic control rather than a process control. And so this can solve some problems and potentially cause others. So some takeaways, which are full of opinions, kind of being formed based on some open questions. So if you can modify your scheduler directly, you should choose a direct integration. It gives a significant amount more power and knowledge to the scheduling system that can help you solve some of these potential reliability issues.
Question. Why does you have to integrate this identity system with the scheduler? They should be decoupled. Why is this? I'm uncertain why this problem. I mean, the scheduler is coupled with the latency of your identity system, like a 7-second.
Sure. So I think in here there is,
Repeat the question.
I will. So the question is, why are these things coupled together? And I think potential way for me to answer this is a hidden assumption that I actually have in our backup slide, which is that ideally we view that your workload registration should be pinned to the host that it is intended to run on. And so what that means is that when your tasks get rescheduled, you need to create new registrations rather than having your jobs that the identities tied to potentially an extremely large pool of resources. So if you imagine that you have a scheduler that's managing tens of thousands of hosts and you want to run a job that only actually runs 5 instances, you should really only want that identity to be available on the location where those 5 instances are running, rather than this entire pool of 20,000 hosts. And so with that in mind, you need to get that information from the scheduler. And so with that assumption, you can either directly integrate this in the scheduler or you can do it indirectly. But by doing it indirectly, you have a different set of reliability trade-offs that you need to be aware of.
I'm not fully convinced. For example, in Kubernetes world, right, the identity can be from Kubernetes service account, which is a job, and the workload can simply, present that job to get in exchange for a certificate. They are not coupled with scheduler. Scheduler is, for example, Kubernetes component, API server. They send a command to, Kubernetes to start something. But that identity seems to be a separate, component, or it's a different flow. So, but maybe I'm not fully understand your context.
Sure. I mean, I also don't have a bunch of experience with Kubernetes. But like my understanding of Kubernetes is that it also has its own set of identity that you need to bootstrap for that platform, right? Is that correct?
That's correct.
And so if you don't have a platform that already has this, right? Like if you want to use Spire for your entire identity platform, then this information needs to come from somewhere. You're suggesting that we exchange one credential for another, and I'm suggesting that I don't have a credential to exchange.
Basically, my concern is why scheduler is coupled with your identity system and seems to induce a large latency. And it seems to be a nasty problem to solve. You mentioned there are a bunch of dependency and timing issues. So I just don't fully understand why they have to be coupled together. Or they can, identity system get a token from somewhere, and eventually the token get exchanged for, SVID. It seems, less dependency or.
I think we should talk about this at 12:30. Yeah. Okay. So to sum up some of the stuff, with all of these assumptions aside, if you are in a situation where you execute on an indirect integration, you need to understand these failure modes because they're, as you mentioned, very complex to reason about, and they can have a really big impact. And so, in this model, my opinion, a workload should have an identity before it takes traffic, because if it can't do anything with that traffic, then your traffic system should be routing around it. You should consider having a workload require an identity to be running, so that you can get feedback into the scheduling system so that you don't have this issue where it just rolls out an entire deployment and nukes it from orbit. And this gives feedback to the scheduling system, which is both positive and negative, because that feedback comes as a form of load, which we talked about a little bit before. Now, if you view that that's not a tractable solution because of this potential outage caused by load, another possible solution would be that you don't require an identity to be running, but you have some sort of external monitoring system that monitors for this and interacts with your scheduling system to pause what it's doing. Because fundamentally, if there's some sort of issue that will cause a new workload to be unable to fetch its SVID, you want to stop taking action because that SVID is being held in memory. And if you reschedule the existing tasks, you're going to cause an outage. That is all I have. I don't know how much time I have. I think we're towards the end of it. But
can you go to the next slide and see? I think there's an agenda.
It's on a different slide deck.
Okay.
I can stop sharing though.
Here, let me see.
We have time for maybe 1 or 2 questions.
What's up, Will?
Obviously new to all this. My question is, do you have general advice for strategies for self-verifying identities within a workload as part of your health check? That seems to be like a baked-in assumption that you highlighted on the last slide.
Yeah, so I think some of like the open source clients that exist in the SPI repo actually already do this, where they validate their own identity against the trust bundle that they got. And so I think depending on the kind of vagaries of your PKI infrastructure, that is probably valid. Potentially, you might need some other information about some like route that you're propagating with a different sort of like propagation model in your architecture. It comes down to the verifier, but it's very likely that you can simply validate yourself against the trust bundle that you have, that you got from that very same workload API.
And do you have strategies for workloads that, or for schedulers that don't allow like customizable health checks? Like if the scheduler was just checking PIDs on a box?
No. I mean, this is, if you look at like Aurora implemented health checks because Mesos only checked that whether or not a process was running, right? And then a bunch of these ecosystems have started kind of adding this stuff more and more and more. And so I don't, outside of being able to get information from that process, then you're stuck with it's alive. I think in that place, then you would likely want to have the process kill itself if it doesn't have an identity, right? Which is actually another thing I have hidden in a backup slide, which is like, how long does something wait for an identity, right? If you started a workload and your health check isn't ready, like in the kube world, you can say like, don't run this check for a certain amount of time because I need to warm up. How do you set that time? What is it, 15 seconds? Is it 5 seconds? It's tied to your propagation delay, but then it's also potentially tied to SLAs for how long rollouts take. And so there's a lot of like very involved, very complex questions here and lots of knobs to turn. And so if anybody has thoughts, I'm all ears because we're gonna have to solve this problem a bunch. And I'm sure there's a bunch of opinions. So it's good to hear them all.
Awesome.
Cool. Thanks, everyone.
Next up, we have Nathaniel from Cloud Identity. I'm sorry. I always get that wrong. From Cloud Identity, who's going to talk a little bit. We're going to zoom out a little bit, less technical, and talk a little bit about how SPIFFE IDs might be used for humans. Just an interesting thing that has been kind of tossed around, but has been mostly out of scope for the SPIFFE project. But Nathaniel's done a little bit of work around it, so he's going to tell us about his experiences there.
Thank you for the introduction, and I will share out a deck really quick and get started. Or I believe I will. Give me 1 second. Well, let's make do and just go from the slide view presentation side. Sorry about that. You know, Macs don't like to refresh screens very much, right? Apple's got a thing about it. So we're going to talk a little bit about the intersection between user identity, SPIFFE, authorization, and maybe even a little bit how that falls into DevOps, right? How can we automate all this stuff and start to bring that user identity context into our SPIFFE identity context and marry those together through authorization? Because we see that as being kind of that next step in the critical infrastructure of marrying, you know, all of your different types of identities to each other. So, wow. The first step of that is rethinking like what does identity mean, right? And SPIFFE's done a fantastic job, SPIFFE, Spire, Sitel, done a fantastic job at bringing service identity right to the forefront. And if we look at what's in a transaction, you know, we see that there's a user, there's a service, there's a thing, and oftentimes there's a data stream. And every one of those needs to be its own first-class citizen in the identity ecosystem. What that means is we have a bunch of user IDPs, you know, from Okta, Ping, et cetera. However, marrying those together into a common context as you're traversing all of your different microservices, serverless functions, workloads, et cetera, becomes more and more important because you want to maintain that context as well as an immutable record of all audit as you traverse all of these different services. So adding that service identity to traditional IAM builds that zero trust ecosystem everybody's kind of nodding towards, but nobody really knows how to get towards, right? Where I can have each and every identity in the ecosystem authenticate and authorize each and every other identity in that ecosystem. And we see authorization as being kind of that common security layer of glue for it. And what that means, like from our perspective, as well as I wanted to bring a customer use case to bear, is as we look at how does cloud adoption actually occur? How do we start to build cloud native services, particularly for legacy corporations? I guess is probably the easiest way to say that. Financial services is an easy one to pick on, and the example of this one, but they were stuck in the past, right? They had about 150 different 3-tier applications that they were trying to say, well, how do we get these to cloud? A lot of them were EOSL'd, all kinds of different problems with the architectures from a supportability as well as a cloud adoption perspective. They're using things like API keys and long-lived OAuth tokens to represent those identities, which is obviously the exact wrong way to do it, at least in the modern era. Not that it's not good for north-south traffic, but for east-west identity of the different services becomes more and more difficult as those are being shared between your different development teams and being applied to a multitude of services instead of independent service identities. They weren't seeing any of that east-west traffic, right? So how can we actually understand what services are talking to what services, how are they talking, and what's the contextual information for that conversation? And all of that led to the inability to meet their GRC requirements. In this case, it was the first versioning of NYDFS, the New York Department of Financial Service, which wants an end-to-end immutable audit of what happens from a user authentication down to the actual data store queries that they're performing. So as some of those steps, what they did is, let's start decomposing our applications to microservices, things that we've all kind of seen. How can we actually proxy the user identity and then direct that into SPIFFE-based service identities and then gain that east-west traffic visibility? All of that gets wrapped up then into a next generation access control standard, which NIST put out in 2014, which really builds upon both declarative security and relationship-based security. And then moving that into an authorization as code to make it very, very simple to consume for both your development team, so they can use the exact same authorization on localhost as they're building out their applications as they use in production when they're deploying it, right? So you no longer have security as kind of this blocker that we've all experienced as developers, right? Where you write some great codes, take it to your security for review, and they stop you right at the front door, right? Because you did something nefarious, or maybe not nefarious, but something that's not kosher, I think is a fair way to say it. So by giving them better guardrails through authorization, you're able to kind of maintain that immutability of those authorization policies from the inception of your development process all the way through the deployment into production. And then as they look forward, how are they planning on moving? Obviously, everybody's looking at service meshes these days and how they can adopt those cross-cloud or cross-platform, hybrid cloud, I'm sorry. How can they bring in higher levels of service attestation, right? So we absolutely love what SPIFFE is doing from that perspective, but then there's the question is, as we spin up all of these different SPIFFE providers and we have all these different CAs amongst our partners, et cetera, how can we do the same level of attestation that became a stumbling block for SAML back in 2004, 2005? Like how do I prove that you authenticated in this way or that you are indeed who you say you are from a service perspective? And then how do you bring in things like adaptive authorization for real-time threat mitigation based upon how those attestations look or how much you trust those different partner services and different partner identities? So here's where they started, and my apologies, it's a bit of an eye diagram, even for me up here. But moving from kind of these big comprehensive legacy platform services and starting to decompose those in common domains of who can trust who, right? So this is the standard decomposition of your legacy application into microservice where you still have your common front door, but you're starting to rip out and rebuild different aspects of that service into microservices as you're decomposing it. And you're able to use, they're able to use their existing identity platform, the user identity platform. I've got to be actually a little bit more specific. Come in through an identity proxy, which is essentially token exchange service right at the front door, and have that translate, the OAuth token or the incoming SAML token, or even legacy tokens, into single-use JOTs that are then being passed between the services on behalf of the user. In addition, there's obviously the SPIFFE JOTs that are going in between the services themselves. And thank you guys for moving into the SPIFFE JOTs. That's certainly appreciated from a enhancement to the spec perspective. But being able to, one, authenticate and authorize each of the services to themselves, as well as then maintain user as well as device context of the requesters, and carrying that across the different domains of services that are present here on the back end. So one of their first goals was, how can we actually get this into the cloud, or get our first cloud app, right? And that was kind of the big win. And they were looking at essentially a 6 to 9 month timeline because they wanted to rebuild all of their traditional perimeter-based infrastructure. In this case, it was in Azure. And so, get an NGFW spun up, get an IDS spun up, et cetera, et cetera. And we said, through the power of SPIFFE and being able to deploy what we think of as naked code, you're actually able to do very robust micro-segmentation patterns as well as authentication mutual TLS patterns between your app. And now you can put it into your VPC, have those connections be able to be performed in real time via the SPIFFE protocol back to your on-prem apps, and use that to build that, or to expand your trust domain for your microservices as you're decomposing and moving those outward. Again, you're doing the brokering at your ingress point for the end user, moving them into single-use tokens that are, again, being passed back and forth across your different applications or across your different services, microservices, functions, and moving those, maintaining that context as well as an immutable audit at each one of your code-based perimeters that are being passed back and forth between your different services. And this is a Spire-based for the SPIFFE SPID, and then also wrapping that in a distributed policy decision, distributed policy enforcement point for the NGAC-based enforcement. And so what the inculcation of that really looks like is we want to be able to have our developers just write business logic. And I think that probably goes for everybody in this room. How can I help the developers move faster? And we've seen really a breakdown, I would say, between cyber and developers, and even though we're kind of all out here talking about SecDevOps or DevSecOps or DevSecOps, whatever your favorite mantra is, the question becomes is how can we, the question becomes, how can we actually start to give value back to the developers, right? Instead of just saying, hey, here's an API to integrate with, we're going to make your life a little bit harder. And so by offloading and externalizing all these different pieces in a service mesh style pattern, externalizing authentication, externalizing authorization, externalizing audit, externalizing your SPIFFE identifiers, you're actually able to help your developers move that much faster. They're seeing a total reduction in code of 20 to 30% on the different microservices as they're decomposing, because all this stuff is just natively handled for them. And that gives you a singular pattern that is application agnostic, that can sit in front of your microservice, your monolith, your serverless function, or even plug into your existing API gateway via an OSGI model. So regardless of your infrastructure, you get those same levels of authentication, authorization, and audit that are so imperative to making sure that both your data is clean, as well as you're getting that mutual authentication authorization between all of your different services. And this is kind of where the rubber really hits the road, right? On the far right-hand side, you're able to create real-time policies of how can services talk to each other within a singular trust domain. Fortunately, they still have a singular trust domain. We haven't tackled the federated trust domain model quite yet. But within a singular trust domain, even across multiple clouds, what do you use for your whitelisting, for your micro-segmentation between those services? And then how do you actually marry that to, well, what was the OAuth scope that came in with the user, the bearer token that the user presented? Or what are some of the fine-grained permissions consent that need to be modeled for that user to assume this role to access that data source on your back-end service? So marrying all those together in both a authorization as code, which is what you see in the bottom right-hand corner, or in a very easily visible kind of decision tree matrix, for your GRC people to actually say, this is how things were progressed, and this is how I know that this service was protected adequately based upon the data source type. You're able to bring all these together and integrate them. I think I'm pretty much out of time.
Yeah,
almost, yeah. Oh, and so that's actually my last slide. If we want to get into more details, I have a few backup slides, but I'll open it up to any questions. We've got one.
So could you give your personnel an SPID directly?
So you're not actually giving your SPID directly. What you're doing is you're exchanging your existing identity context for a single use. It's almost like a SPID jot, but it's not exactly an SPID jot that is being passed between the services to represent that user context.
So what's the benefit of that compared with just giving them an SPID?
Well, the benefit in this case is it's a single use token as opposed to a multi-use token. So if we were to mint an SVID jot every time, right, we'd have the stampeding herd, especially for lots of transactions per second. So by proxying that off and then moving that into single use, we tried to avoid that problem.
Actually have a security token service model that are exchanging an OpenID Connect token for a jot SVID or something.
Yes.
Can you restate the questions, please?
Oh, do you actually have a security token service model where you can exchange the OIDC, SAML token, whatever it is, into a jot or into an SVID jot? And the answer was yes. And so that's happening right at the edge as you enter the data center or as you enter in through your API gateway. That's where that translation occurs. And that minting occurs either as a plugin or via edge microperimeter is what we call it.
Your first slide, you had devices, like there's like a mobile phone.
Yeah.
And there's like a secure enclave. Are you working on like attestation of mobile devices?
Yeah, so we've got a pretty interesting thing that we've been doing with ARM, where we actually took a lighter weight version. Well, it's actually a completely rewritten proxy now of Envoy, but it's written in Go, and then married that together with Spire and can actually get deployed on smart devices. It's just under 8 megs, so it's quite small. And then you're able to do that distributed policy decision point as well, in which case you're able to say permissions consent evaluation at what we call the microperimeter into that smart thing or that smart device to make the determination of who can actually touch what data parameters or what URIs or what backend APIs on the smart thing.
How do you attest that though? What do you use as the basis?
So the attestation actually comes from the secure enclave in embedded Linux or on the process itself, depending upon who the manufacturer is.
You might have just answered this, but what would you suggest in cases where you don't have an edge?
Where you don't have an edge. And so that's the whole idea of naked code. And that is what the microperimeter is actually designed for, right? So I can take that and deploy it anywhere because we're looking at 5G, cottage cloud, things of that nature, where you no longer necessarily have any edge. And so the microperimeter acts as either the defined edge, and you can add filters to it that will do OAuth token brokering. It won't do like the full gamut to your question, but I think it does OIDC and OAuth right now to create or to either translate bearer tokens or even to look at user credential flows. And then, or you can have it call back centrally, obviously back to your data center, but then you lose your online offline capability, which in things is so important.
So I might have misunderstood where that micro edge lives. That seems to me to be the user's device, but maybe that's the server.
No, the microperimeter is actually on the service itself.
Okay.
Or on the thing itself now. And
so if you don't have an edge, then all of your services have to understand the external type of tokens. They can't use the internal tokens.
Correct. Oh, well, let me clarify that. So if you don't have callbacks to an edge, right, then then that's correct. So you can either do the callbacks, or if you're looking for online offline modeling, which is becoming increasingly important in our world, then you don't need it. Then you have to be able to broker the token at the microperimeter itself instead of the microperimeter edge.
Yeah.
Okay.
Yeah. Thank you very much.
Yeah, thank you. I appreciate the opportunity today.
All right, so we're almost towards the end here. We've got just a few more demos that we'd like to show you, some of the stuff we've been working on. So the first up, I think, is Scott, and he's going to show Spire working on Kubernetes and some of the latest integration works that we've done around that.
Give me just 1 minute to get the presentation started here.
All right, so I'm going to talk a little bit about Spire in Kubernetes and then give a demo. The demo uses the new bundle notifier that Andrew Harding mentioned earlier. So you'll see that there is no bootstrap CA or upstream CA. Spire just handles all of that by itself. And I have just a couple of slides to talk about deploying Spire in Kubernetes. These are things that are fairly general. They don't apply just to Kubernetes, but I'll talk about them kind of in a Kubernetes realm. So first up, you're probably going to be deploying Spire Server as a stateful set. And the reason for that is if you want good resiliency and availability, you're going to need the data dir to be on a persistent volume. So if you're familiar with stateful sets in Kubernetes, you can have a volume claim template that automatically creates volumes for you and mounts them up, which makes managing the cluster fairly easy. And production environment, you're going to need a shared database. Currently, that can be Postgres or MySQL. And if you follow all of these rules, scaling out the number of Spire servers is actually pretty easy. You need some sort of load balancer or round-robin DNS today, so that the agents can talk to the servers. There's still some work to do around that, but it's fairly easy. You need to be aware of one thing, and that is that the certificate bundle is really kind of eventually consistent. It's not synchronous. So as you deploy additional Spire servers, it'll take some time for that certificate to be replicated to all of the other Spire servers, so agents will trust the new server. This isn't a problem if you're doing rolling upgrades and you have a persistent directory for data dir. It's just if you're rolling out a new server, because the agent won't trust it until it gets that server certificate in its bundle. So because of that, you just need to be careful about deploying servers in kind of a controlled and rolling manner. For the agents, in Kubernetes, that's really going to always be done as a daemon set. That makes it really easy because the agent will automatically start up on each of your Kubernetes nodes. Depending on which attester is in use, you may require local storage for the data dir. Not persistent storage, just local host path. So if you're using the service account token or projected service account token attesters, you don't have to worry about this because a node can attest multiple times. If you're using the instance ID attester for AWS or Google Compute or the MSI attester on Azure, you can only attest once. Right? Once that agent has attested to the server, it can't attest again. So that data dir needs to be on the local node so that if the agent crashes and reruns, it's not trying to reattest as a new agent, which will be rejected by the server and none of your workloads will work. And then finally, just a really kind of a nuance of, so you've got the agent, it has a workload API Unix domain socket that your workloads need to talk to. So you need to be able to expose that socket to each of your containers that are running your workloads. And you need to make sure that you do that as a directory, not just exporting the individual socket. Otherwise, if your agent crashes or is respawned, that's going to be a new file and all of your workloads are no longer going to be able to talk to the workload API, which is a problem. So I'll go into that configuration in just a little bit more detail, just because it's always fun to look at YAML on a big screen. So you need a volume mount. We'll put it in run Spire sockets, and read only is false, right? Because the agent needs to create that socket. And then for the volume, we do directory or create, so that if that directory doesn't already exist on the host, it'll get created. This might be a little bit mind-bending for the workload. We set read only to true. Actually, you can still talk on a Unix domain socket even if you do not have write access to the underlying file system. So it's really important that your workloads, you set read only true, because you don't want your workload to delete the socket. Because what would happen with any other workloads running on that node, right? They wouldn't be able to talk to the workload API. And then for the volume, just directory, because we never want the workload to be able to create that. And then just a little bit of discussion on registration entries. Matt did a really great deep dive into kind of how they do their namespaces and map all of that out. But I think you really need to kind of take a step back and think about how you want to architect your naming scheme.
You can create hierarchies or groupings in kind of a way that is logical or natural for your workloads. If you're using automated registration entries, then the following doesn't apply. But if you're creating manual entries where you're going to the Spire server and creating an entry, and you're using a very, very specific thing, like here's a GUID from the service account token attester, or even a host name or anything at that level, you might want to take a step back and think of another way to architect that. Because if you have to manually create one of these every time a node comes online or an agent restarts, that's probably not going to be a manageable situation. So here's one way to do it. So I have two workloads, workload A and B. They're going to run on some set of nodes. So I'll map that into a SPIFFE kind of naming scheme. So I'll have my cluster nodes, which all of the nodes will attest into. And then for workload A and B, I'll map it that way. And then from there, I can go and create those entries. So we create a parent node with the /node or -node type of entry for the nodes. We create a selector so that any nodes that are running inside of that cluster will get that SVID. And then for the workloads, we have a parent that points to the previously created entry. And then whatever selector is appropriate here, we're just using a service account for workload A and B. All right. So I'll go ahead and do a demo of this. As I mentioned, we'll be using the new bundle notifier. So to start with, so as you may be aware, Customize is now built into Kubernetes 1.14, so I've started to use it for my configurations. Your cluster doesn't need to be running Kubernetes 1.14, just the local kubectl where you're running it. So if you haven't seen customization YAML, this is kind of what it looks like here. So we're going to create a config map for Spire Server, where we'll inject the Spire Server configuration. Exact same thing for Spire Agent. This kind of strange thing, maybe that it's for Spire Bundle, we're going to create an empty config map for Spire Bundle. And this is going to be populated by the bundle notifier that I mentioned. And we'll see what that config map looks like a little bit later. And then in Customize, resources is just a bunch of YAML files that will get assembled and run when we apply this configuration. So let's take a look at the server configuration. So most of this is exactly the same as the example, the Kubernetes service account token example that is on GitHub. So I'm only going to kind of mention a couple of differences. If you look at our current example, it's using an upstream CA, whereas this one, we're not. We're using this new K8s bundle notifier. So this is all we need to do in the server to use the bundle notifier, using all defaults for everything. Otherwise, you might have some additional configuration there. And then let's take a look at the agent. So if you've done other configurations, usually what you have for Trust Bundle Path is a Bootstrap CA, right, or Bootstrap certificate. And this is what the agent uses to initially attest to the server. And this is actually something that's going to be created now by the bundle notifier. And let's go take a look at Spire Server deployment. So the Spire Server does not load this config map. It doesn't get mapped into it. That happens through the Kubernetes API. Does that make sense? So that config map, that empty config map for the bundle, we don't mount that into Spire Server. We mount that into Spire Agent. Spire Server uses the Kubernetes API directly. There's some roles and other bindings that need to be created for that to happen. But I do want to mention this. So in a stateful set, what a volume claim template will have Kubernetes automatically create and allocate and attach volumes for us, so we don't have to manage those separately. Let's take a look at the agent. So I mentioned that we need to mount in that config map. So here we see Spire Bundle, and that is just, where is it, the config map here. And then the socket configuration that I already showed you, I already talked about. And that's pretty much it, rather than showing more YAML, as much fun as it is. Okay, so on the right side, just run this little script in Watch. So we can see I'm running in Minikube. It'll dump out the service accounts in the Spire namespace, as well as the pods once we deploy it. Whoops. All right, so over on the right, you'll see the Spire server is pending, and now it's running. And now we have Spire running in Kubernetes in seconds. Yay. You take a look at the logs. I probably won't look at those too much because that's just too painful to look at. So I mentioned the volume management that we get by using persistent volume claims. So you can see here that Spire data, Spire server 0 is a volume that Kubernetes automatically created and injected for us. And I promised that it's actually really easy to scale the Spire server, right? So let's do it. Oops. Oh. All right, so guess what? Now we're running 2 Spire servers, that easy. Now I'm not running with a real database, so that Spire server is completely useless to us, but if I was, it's really no different. One thing I meant to mention that I will show you now, bear with me here. Service.yaml. So here I'm just using a simple Kubernetes node port load balancer. This could be a real load balancer if you're running inside of a real cloud environment, right? But that's an important detail. All right, I'm going to scale back down to 1 server, and I do want to show one thing. So Kubernetes stateful set does not delete the volume when I scale down the servers. So if I was to scale the server back up, it would just reattach that second volume to another pod. Right, this is kind of important when I mentioned earlier about persistence, so that any of the state about that server, right, the new server will be able to kind of take its place. So that's just important piece to understand for doing rolling upgrades. And then let's do this, describe config map. Oops. So that empty config map that we created, here we can see that the Spire server has now injected bundle.crt into it, so that's how the agents, when they start, are able to bootstrap, is they actually get the bundle. All right, now let's look at a client workload. So instead of running like a real workload or anything, I'm just going to launch a Spire agent container and have it sleep so that we can exec into it and see a workload in action. This is mounting up the socket in exactly the way I described in the earlier slides. Well, let's apply that configuration. Hop into the pod. And then let's get ready here. It's a real demo. You get to watch me type. Okay, so this is going to fail because we don't have any registration entries, right? So that's great. It's expected. Okay, I won't type this out. I will run this as a script. So here we're going to create some registration entries exactly in the way that I earlier described. We're going to have a first entry, which is going to be for the node attester for the node, and then another one for, well, it's not a very good one because we're just attesting on the default service account, but it's okay. And so now if we get that guy running and we register, there we go. We have a SPIFFE ID. So, yay. That's it. So it's with these configurations, it's pretty easy to get started and just kind of play around a little bit and kind of see how everything's wired together. That's it. That's all I have. Any questions? All right, I'm not sure who is next.
Thanks, Scott. So I think we've got Spike next. Spike, are you on?
I am.
Oh, there's a question in the back. One second, Spike, sorry.
Are you going to make that demo publicly available?
So the question is, am I going to make that demo publicly available? I can. I actually want to put this configuration in the examples that's using customized because I think it's just pretty easy to use and, well, customize to run on a real cluster.
All this is recorded.
Yeah, but we can check this into GitHub. It's easy enough to do.
There's a question from Michael.
Question?
What was it? Question else. Right? Is that question?
Can we go to here?
If the agent still requires privileged access to the host process ID. That's from Michael Payne.
Yes, so it still needs access to the proc file system. Yeah, and running it as a daemon set, like you'll notice, well, if you look at these configs, I'm not running it as a privileged container, but because it's a daemon set, it's already kind of inherently privileged in Kubernetes. It can do things like talk to, even in Kubernetes 1.14, it can talk to the insecure kubelet port, which nothing else can do. All right.
Thanks, Scott.
Yep.
Thanks. All right. Next we have Spike. Spike from Tigera. He's going to show an integration he's been working on with Calico, Envoy, and Spire. So take it away, Spike.
Yeah, this is actually good planning on the ordering because the demo that I am going to show basically builds on top of what you just saw. So I have Kubernetes cluster. I'm running Spire in it. Actually, I'll present my screen. Let's see. Does that? No. I think, okay, so I'm gonna have to like mess around with what I'm presenting because I actually have two monitors, and so presenting sort of both of them at the same time doesn't work, but I also want to show multiple windows. So anyway, what I'm going to do is sort of build on top of what you've just seen, which is Spire running in Kubernetes. And if you think about what we want to accomplish at the sort of high level with SPIFFE is to be able to have secure communications between services, right? And so in order to do that, you need to have identity, you need to have authentication, and then you need to have authorization or access control. Basically, deciding whether or not, once you know the identity of the person that you're talking to, whether or not you're going to allow them to do whatever they're trying to do. And so Spire is going to handle that identity using the SPIFFE standards. And so the question is, well, what are we going to use for authentication? What are we going to use for access control? So one thing that you could do is you can just write that into your application, right? You can use Spire. That'll get you your certificates. You check the certificates before you set up the connection. You use a TLS library. You write your own access control, and that's all sort of one way that you can go down that. But I think what a lot of people are interested in is having something a little more turnkey and transparent, and in particular this kind of architecture where you keep the business logic of what your workload is trying to do in a separate process from all the interesting networky stuff. And this is, that architecture people refer to as service mesh. So you have a proxy that handles all of the network. So you're going to delegate that delegate the identity, the authentication, and the authorization all down to this proxy, and then control that proxy or configure that proxy either with a central controller or with config on disk or something like that. And so Envoy is a great example of one of these proxies that's specifically designed for this kind of architecture. And so some people are thinking, okay, well, I want to use Envoy as my proxy. And one thing that you could do if you wanted to use Envoy as your proxy and do this transparently is to just download and use Istio. Istio uses SPIFFE standards. It has its own kind of identity framework, but nominally you're still getting SPIFFE compatible SVIDs out to your envoys. Envoy will handle setting up the mutual authentication, and you can use something like Calico or something like Istio RBAC to do the access control. But there are a lot of people that we talk to that are not interested in doing Istio, and that usually is one of two reasons. One reason might be that Istio is too many things for what they want to do, and they want to build something that is kind of conceptually and sort of actually simpler. If you hear talks from Matt Klein at Lyft about what they're doing with their service mesh, they're pioneers in this space of service meshes, and they have these controllers for their service meshes that are measured in hundreds of lines of code rather than the several million lines of code that shows up in Istio. And some people, so that's one reason, is maybe you want something a little more lightweight, a little more simplistic. The other reason is that people have very exacting requirements, and Istio has kind of chosen one direction, and they don't want to go that direction, and they want to roll their own because they have their own kind of exacting requirements. So there are various reasons why you may want to be kind of going your own way in terms of the rest of the service mesh controller, but you still want to answer these questions about identity, authentication, and access control in a way that doesn't require you writing a bunch of code. And so what I'm going to show you is a way to do that using Spire for identity, Envoy for authentication and the encryption, and then Calico as the thing that is going to do your access control. And that also gives you the advantage that you can use Calico if you're already doing network policy in Kubernetes. You'll have Calico or something like that, and you can sort of directly expand from the network policies that you have all the way up to these cryptographically backed policies that you can use once you have a cryptographic identity plane. Okay, so here's the architecture of what we're gonna show. So you've already seen how Spire works on Kubernetes. So I just have one box drawn for Spire, but actually there's a server, there's agents. But at the end of the day, Spire is going to be responsible for getting identity certificates out to the pods that are our workloads. And we're going to configure Envoy to be that proxy. So all the traffic from my workload is going to traverse Envoy. And Envoy is going to transparently intercept that traffic and upgrade it to mutually authenticated TLS. So that's going to be the authentication piece. And then for authorization, we're going to be running a small, lightweight service inside the pod, which we call Dikastes, which is Greek or ancient Greek for the decider. And that is going to apply the access control policy. So when a request comes in, Envoy is going to ask Dikastes, should I allow this request? Dikastes will apply the policy and say yes or no. And Dikastes communicates with the rest of Calico's control plane, including Felix, to get the policy for that particular pod. So Felix tells Dikastes what the policy for that pod is, and then Felix is also doing some extra layers of enforcement. So Envoy is enforcing up here at layer 7 and cryptographically, but we're also getting some backup enforcement out at the node layer using IP tables. Okay, so the application that I'm going to show you for my demo is very, very simple. I call it YAO Bank, which is yet another online bank, and it just consists of 3 services. So there's a customer microservice. This is the end user thing that customers hit to look at their bank balance. It calls a microservice called the summary, which provides their account summary, and that's backed by a persistence layer, which is the database. Okay, and so like I said, this is a very, very simple application. Here's what it looks like. It's running in Minikube. And if I hit this full set of pods, you'll see that I have Spire running. I've got all my Cube system stuff. I have Calico running. And then the application itself is running in the default namespace. So I will skip over all of the initialization steps that bring up the Spire server and the Spire agent. It's probably worth mentioning what SPIFFE IDs I am creating. So just like Scott was talking about, I'm creating.
See your screen.
Oh, sorry. Right. Yes. Thank you for the reminder. I need to stop presenting and then represent a different window. Okay. Can you see that?
Yes.
Yeah. Okay. So so I've got some steps here that are creating the Spire server, creating the Spire agent in Kubernetes. Those are more or less what you just saw. It's probably worth talking about what entities I am creating. So basically, just like Scott was talking about, I have one entity that's representing Kubernetes. And then I have 3 different identities, each representing a single service account. So there's a customer service account, there's a summary service account, and a database service account. So each one of those microservices that I just talked about is going to be running under its own service account. And then I have the YAML for the application itself. And so as you would expect, I've got a service and a service account for it. I'm going to skip over this config map for just a moment and look at the deployment. The main kind of thing that the workload is just unchanged, right? This is exactly what I would do if I wasn't doing any of the SPIFFE stuff and just doing this insecure over HTTP. But I have some extra containers in here in order to make this stuff work. So I'm actually borrowing Istio's init container here to do the proxy redirection. So this is a container that comes up and sets up IP tables to redirect traffic into Envoy from inside the pod. And so I'm doing basically the same thing Istio does. So I just borrowed their container. And then I have a copy of Envoy itself running inside. And as we just discussed, I am creating a volume mount that gives it access to the Spire sock. And I'm also giving it a volume mount that gives it access to Decastes. And then I have a Decastes container running and some other mounts that allow Decastes to talk to Felix. Okay. So then we get into the sort of the more complicated part of how you actually get this stuff working, which is like, what is the configuration that I should give to Envoy? And I don't have time to go into all of the nitty details of what goes into an Envoy configuration, because it's very verbose and sort of very declarative. And so I'll just hit the highlights here. So Spire has a beta implementation of being able to talk over what's called SDS, the Secret Discovery Service. So Envoy doesn't talk the native workload API that Scott just demonstrated. It talks a slightly different API called SDS in order to exchange certificates and keys. And there's support in Spire for being able to talk over SDS. So I'm configuring Envoy to talk over SDS, and in this case, this is the database. Actually, I'll grab the summary microservice, since that one talks to 2 different things, and so it'll be acting both as a client and a server. So the summary microservice, when it is accepting connections, right? I'm under the listeners here. I am going to require that I get a client certificate. I am going to provide a server certificate, which is my SPIFFE ID, that summary microservice. And this tells it to get it over SDS. And then I'm also going to tell it that when it validates those client certificates, it should do it using this trust domain. And when you use this trust domain name over the SDS, Spire is going to give you the trust bundle for that trust domain. So that's what happens on incoming connections is this guy presents this identity and checks the identity of the client using this trust domain. Now, when I'm making connections out, so this guy's configured to talk to the database, so that clusters is Envoy speak for making outbound connections from the proxy. Here, the TLS context, I'm going to say validate the server using, again, that trust domain. Verify that it has this SPIFFE ID. because that's what I know is running the database, and present this client identity. Again, all got over this secret discovery service. And then the other configurations here basically look more or less in the same pattern as this. They're configured to know, what identity they should be presenting, what identity they should be seeing on the other end, if it's a server, and which trust domain they should be validating against. Okay. So then, I can refresh my application and see that yes, it is working. I have this stuff working with TLS. So then the last piece, I've got identity, I've got authentication. The last thing that I want to do is do access control. So for example, if I kubectl exec into, say, the customer microservice and try and access the database.
Do we need to see another window here?
Oh yeah, sorry. I'm just totally forgetting that that step. Let's see. Okay, see my terminal here.
Yes.
Okay, right. So if I kubectl exec into the customer microservice, oops, that's not the container I wanted to be in. Then if I curl the database, then you can see I can access that, and I can actually dump the whole thing, and I'll pipe that through Python JSON prettifier, so you can see what's actually in this. And so I can dump the whole database here. I can get names and account numbers and balances, and this is the kind of stuff that hackers want. So I definitely don't want to be able to get to that directly from the customer microservice, because that is the one that is most likely to be compromised by an attacker, right? It's the one that they have direct access to. If they find a vulnerability in that and could do remote code execution, they could get to my database. And I don't actually need that connection in order for my application to run correctly. So I can use, and I'll cat this rather than show you in the editor so I don't have to switch again. I can use Calico's network policy to express the access control that I want to enforce here. So for anyone that's not familiar with Kubernetes network policy or Calico network policy, you use a selector to tell it which pods this policy should apply to. So for the customer pods, I want to allow just anybody to do a get, as long as they're doing a get and not like a post or a put. Anyone that could connect to that thing should be able to do it. But for these backend services, the summary microservice, I know the only thing that should be connecting to that is the customer microservice. So I'm using a selector here that is referring to Kubernetes service accounts. And so we know kind of from the SPIFFE IDs how to translate those SPIFFE IDs into service accounts. And then for the database, I only want to allow connections from the summary microservice. So if I create that policy, and then reconnect to the customer microservice, and sort of try again with my, let's see, hide that. This guy here, you'll see that I don't get anything back. And if I make that a little more verbose, actually, I think this is, yeah, I'm not able to actually get that connection. Alrighty. Any questions about that? I'm hearing some shuffling. Is that like microphones going around, or there's stunned silence? No questions.
I don't see any questions here. Thank you very much for showing us that. Thank you for that. We'll be giving a version of this demo at KubeCon EU also, if you guys are going.
Oh, and this demo is currently up on GitHub. It's github.com/projectcalico/spire-demo. So you can go ahead and pull this down. It'll set up Minikube for you and install Calico, all of this stuff, and you can see how it works.
Awesome. Thank you again, Spike. We got one last demo for you before lunch. I know you're all hungry, so won't be too bad, I promise. So we got, I guess, I don't know if Eugene's presenting, but we're going to do a demo of integration between Spire and Istio. So take it away, Eugene.
All right. Yes, I will present. Right, so I'm going to be showing a demo of, or actually my colleague is going to be showing a demo of Istio integration with Spire. For those of you not familiar with Istio, Istio already uses SPIFFE SVIDs under the hood for MTLS communication between its workloads. It creates a set of SPIFFE IDs according to a common pattern that you see here with the trust domain and the namespace and the SA name coming from the Kubernetes system. What we're going to demonstrate is a microservice running in Istio talking to another microservice that is running entirely outside of Istio and that uses a SPIFFE ID on a pattern that does not match this. So we have a very basic demo here. We have a very simple Istio mesh with a single pod with a web service in it that, in order to function correctly, has to connect with another workload that's running in a Docker container off the mesh. So we install a Spire server on the off-mesh side and a Spire agent, which then attests to the Spire server using one of the standard node attestation plugins. We register a workload policy to the Spire service, in this case, just using the label of the Docker container. We propagate that down to the Spire agent, and now the workload's ready to attest. And the Envoy proxy in the container then retrieves an SVID via the SDS API. Now, to get the thing talking to the Istio side, we do a manual call to the Kubernetes API, in which we use to retrieve a credential, a bearer token, and a certificate that we can use for the token review API. This is probably not how you do it in the real world, but it's a method that works for the demo convenience. Now, we have created, and you see here, two new software components. One is the Istio Node Attester plugin, which is a plugin for the Spire server, which handles the communication with the Istio mesh. And we have created for the Istio node agent, a Spire CA client module that will allow Spire to replace the standard Istio CA for all of the SVID creation, all of the SVID signing that we're going to do. So after making that initial call, we now have a service account bearer token and a service account certificate on the off-mesh side. On the Istio side, Envoy uses the SDS API to request a secret from the Istio node agent, sends a signing token and a CSR, which is then forwarded to the Spire server over the Spire node API.
which we now have there, and we now have all the credentials that we need in order to call the token review API, which we do, sending the signing token to the token review API authenticated with the bearer token, the service account, and the certificate, which allows now Spire to sign the CSR, which then through the Istio node agent returns an SFID to Istio. At this point, we have two SFIDs, one on each side, used by Envoy on each side, that are signed by the same authority and use the same trust domain. And so we can establish MTLS communication. The authorization on the Istio side is done through a destination rule, which we'll show in a minute. Another way to set this up, which you'd probably use if you're using this in the real world at this point, would be simply to run the Spire server in the Kubernetes, in the Istio mesh itself, in which case you wouldn't have to worry about bearer tokens and things of that sort. Do you have any questions before we show the actual demo?
So there is the root of trust is the single root of trust. There is no federation.
Yes, that's right. So we're using. Yeah, I say he was asking if the root of trust was the same on both the sides, and the answer is yes. We're not using federation here.
Similar question: how much of this work would be not needed if there's federation, and how much would be the same?
So if we could just federate between Istio and Spire, you could obviously create MTLS connections that way. If you want to run things essentially in a more connected fashion, perhaps use this to extend the Istio mesh to off Kubernetes use, then obviously you'd want to do things within a single trust domain.
Yeah, the one thing that we need support for would be distribution of federated bundles from the other trust domain.
Yeah, obviously, yeah, that would. So Max, do you want to run the demo now?
Yes.
Oh, sorry, one more question. I missed it.
Okay, thank you. So what's the identity that you are using on the Istio side? Is it service account or service name?
On the Istio side?
On the Kubernetes cluster side.
Yeah, we're using, for the Spire server, we create a service account name called Spire. We don't obviously create an account for the off-mesh workload. We're using a destination rule for the authorization there.
So basically the question is, what's the identity in the certificate that you are giving to the workload that is running in Kubernetes?
That is one that is created directly, basically through the same means that you would in a standard Istio. So it uses the namespace and then the service account name then just according to the standard pattern.
Cool. So in order for your out of Kubernetes workload to talk to the workload inside the Kubernetes, I assume you need to do something like secure naming.
Actually, well, in this particular example, yeah, since we're calling out from Istio, we don't have to do that. But yes, we would have to do it. Otherwise, either doing that or telling the service in the Istio mesh to take the entire value of the SPIFFE ID and to allow that, which also works. We've found. So awesome. We don't actually have to use the Istio pattern, though we probably would if we were doing it for flexibility reasons.
Cool. Okay. Thanks.
Okay. Max?
Yeah. Let me share my screen. Okay, let me know when you see it. Hello, everybody. I'm here talking from Argentina. My name is Max Lambrecht, software engineer at Scytl. And I have here this environment set up as it's the same environment that Eugene was talking about. Istio is running on Kubernetes in a Minikube. We have this web app running inside the mesh on a pod where runs an Envoy proxy that acts as sidecar, and it's consuming data from an API running off mesh, and that connection goes through the Envoy proxies using mutual TLS, using SBIT certificates that are provided by the same Spire server. So Spire acts as a CA authority for both Istio Node Agent and Spire Agent. So you can see here I have the Istio pods, and the application is running on the default namespace. So I will show you some piece of configuration for the Spire server. This is a Nota tester we have added for Istio, and basically this binary handles the attestation of the Istio node agent, and is configured with this file that basically has the token to contact this token review API from Kubernetes. Then for this workload running off mesh, we have a registration entry that gets this, that will sign SBITs with this SPIFFE ID, and is using a Docker attestor using the image ID. So the task API running off mesh is running on a Docker container based on this image ID. So I will show you some logs. These are the logs of the Spire server. You can see that it's signing SBIT with SPIFFE ID from the backend, and it's rotating every 5 minutes. So there's a lot of logs, and this is this SPIFFE ID for the workload running inside the Istio mesh. And we can see here, this is the logs of the Istio Node Agent. Istio Node Agent is pushing through SDS, through Secret Discovery Service API, is pushing the root certificate to the proxy in the task pod, and is pushing the SBIT as well, and the CA is being rotated as well. And so now, in order to be able to establish this connection from the Istio mesh, we are using a service entry that basically defines a host name with mapped to this IP, that is IP of mesh, and on this port, and to enforce mutual TLS on the request to that host and port, we're using a destination rule with this mode, and we are checking that the SBIT presented by this Envoy workload contains this SPIFFE ID. So now if we go, we will make a HTTP request that will go through this gateway, and we'll go to this web app. And it will show a simple page listing a list of tasks that is provided by this task API. Now we will try to change the destination rule and accept a different SPIFFE ID and see what happens. So I will. So basically, now I am applying this destination rule with a different SPIFFE ID, and I need to recreate the pod because Envoy is caching the connection. I need to a fresh connection, so the SPIFFE ID is validated again. So just a second. It's taking forever. Yeah. Then now, if we refresh the page, we should get a 503 service not available because this connection could be established. If we take a look at the logs of this envoy, we'll see that there was a handshake fail when it tried to verify the certificate presented by the other envoy because of the SPIFFE ID not recognized. So now if we apply again the other destination rule, say make success, go to the page, and the connection, mutual TLS connection, is working again. And that's it. Thank you for listening.
Any other questions?
Maybe on the online.
Any questions on the chat? Nope. Great.
Thank you.
Thank you. I know we went a bit. We're sharing the screen. So everyone, thank you so much for coming. I think it's a fantastic turnout here. I saw on the Hangout that we had the same number of people. The count just kept going out, so I guess we didn't bore people too much on a Friday. It's great to see the community growing. Thank you so much for everyone for contributing, especially Evan. You've been driving all the content, all the demos. Our friends from Uber and Square, you guys make it happen. Thank you for telling us your stories. And we'll post this deck by early next week, and Jeremy will get the video files edited just a bit, and then we can post it to the community for people who missed it, if you want to share with your colleagues. Once again, thank you so much. For folks on Hangouts, we'll be turning it off now. And for the folks who are in the office, we have lunch outside. Thank you.